There's a lot of people out there looking at X, Y, Z biomarker, your epigenetic age, your blood glucose levels, lots of different things that you can look at. But it turns out that cardiorespiratory fitness really is the prominent marker for longevity.
When it comes to making sense of nutrition, fitness, disease prevention, and longevity, few translate the complexity of evidence-based science into practical advice for everyday living as effectively as Dr. Rhonda Patrick, a PhD in biomedical science, who has devoted her career to understanding the many ways lifestyle choices impact our health span, and effectively communicating her findings to millions via her platform, Found My Fitness.
If you're willing to go 3 times a week, do 30 minutes of 80% max heart rate, then studies have shown that can have an effect on your blood pressure that's comparable to taking an antihypertensive drug.
Wow.
And I think exercise is the most important thing.
What I admire about Rhonda isn't just her scientific rigor, it's her ability to help us apply this knowledge to improve our health, our fitness, and our longevity. Rhonda has a gift for effectively distilling what matters most into strategies we can all benefit from adopting. This conversation is a bit of a two-hander. The first part focuses on the benefits of vigorous exercise, not only for the body, but also for the brain. In the second part, we discuss microplastics, their omnipotence, the hidden dangers on brain and body, and the strategies we can adopt to avoid them.
We're really in the infancy in understanding microplastics and what they're doing to human health. We're consuming them, through our water and our foods, and we're also breathing them in through the air.
In terms of risk and danger, where should our attention be focused?
When it comes to the worst offenders, first of all,
welcome. It's really good to see you. This is long overdue. There are so many topics that we could cover today. It's absolutely infinite. And I know anything that I throw at you, we could probably spend an entire podcast on. So I think what we're going to do today is pick 2 topics and focus on them. We're going to start with fitness and the impact of different versions of fitness and exercise on the various aspects of health. And then we're going to, in the second half, turn to microplastics, which has been your kind of focus as of late. You've done a lot of work in that regard. So let's start with fitness. Maybe we can begin with just explaining the different varieties of it and how we should think about the distinctions between endurance, strength training, and HIIT, which is high intensity training.
It's funny that you want to start with fitness and talk about the different types of fitness, because I've really, over the last couple of years, particularly last year, I've gone on a really personal fitness journey myself, and largely as a consequence of diving into the various types of fitness on my podcast and interviewing these experts in the fields of, cardiovascular exercise, endurance exercise, high-intensity interval training, and then strength training. Strength training and I would say resistance training are the areas that I have always lacked in just throughout my life. I've always been more of a cardio junkie, someone that likes to go for a run or a bike ride, jump rope. But which you do, by the way, sorry to interject, which I did not know you do with our mutual friend, Hilary Biscay. I do.
I didn't know that you guys knew each other.
We train, yes,
yeah, that's very cool.
She's awesome, by the way.
She is.
But strength training and resistance training, focusing on muscle mass is something that I didn't really, I always thought I was covered if I focused on my cardiovascular health, right? Mm-hmm. And I just, over the years, started to realize that wasn't really the case. And if I didn't spend more time engaging in resistance training and trying to build muscle reserve and build up my muscles, then I would probably regret it, later in life as I'm aging. And so talking about the various types of exercise, you probably can explain this better than myself because you're an endurance athlete. So there's cardiovascular exercise that is, stressing your heart in a beneficial way, and your cardiovascular system, your vascular system. And typically people, when they think about endurance training or cardiovascular types of exercise, they'll think of, it doesn't necessarily have to be really hard exercise, but you are doing something that's making you breathy, right? So a lot of times people will call this zone 2 training. So you're able to hold a conversation, but it's a breathy conversation, right? You're getting your heart rate. And, some people will, depending on their fitness level, you can get your heart rate up to 70%, your max heart rate. Other people that are more athletic, it might be different. So, heart rate's kind of just a gauge, I think, there's a lot of personal variation there in terms of the heart rate. And then there is more vigorous intensity exercise, right? And vigorous intensity exercise is when you're really getting your heart rate, I would say above 80% your max heart rate, closer to 85% your max heart rate. So you're not really able to have a conversation when you're going harder like that. And you can only go for so hard for so long. So, high intensity interval training, there's a variety of different types of it where you're going for these bouts of vigorous exercise that can be 80% max heart rate, or it can be 90% or 95% for a very short period of time. You're not going to go that hard for that long, right? So it's sort of interspersed with the resting intervals as well. But I like the term vigorous exercise because really vigorous exercise is just referring to you're really working hard. And a lot of times when you're going into that vigorous exercise arena, when you're getting into that 80% max heart rate or above, you are working your muscles really hard, but also your cardiovascular system really hard in a way that you're producing something called lactate. And this is, I think, really essential for the vigorous exercise story because typically when you're engaging in cardiovascular exercise, the way your muscles are producing energy is through the mitochondria, which are these little tiny organelles inside your muscle that use oxygen to make energy. But when you're working really hard, the oxygen can't get to your muscles quick enough. And so your muscles, they sort of adapt and they start making energy just using glucose without the mitochondria. And as a byproduct of that, you produce lactate. And the reason I'm talking about this is because it's very important, I think, to the story of vigorous intensity exercise, because lactate for a long time was thought to be a metabolic waste product, right? It was like, and if anything, it was thought to be harmful. It was causing muscle fatigue. It was making your muscles burn more. And we now know that's not necessarily the case. But what's been sort of uncovered over the last, I would say a couple of decades is that lactate itself is a signaling molecule and it's an energetically favorable molecule as well. So the lactate that your muscles are producing are getting shuttled to other tissues, including the heart, the brain. And not only are they being used as energy by the mitochondria, an energetically favorable source of energy. So in terms of it's actually easier for your brain to use lactate than glucose as energy. It costs more energy to use glucose as energy than it does to use lactate. So it's energetically favorable. But what's even more interesting is that lactate is also increasing the expression of other genes. And this is happening in the brain. And it's what's called a signaling molecule. So it's a way for your muscles to directly communicate with other organs. And it does this by saying, hey, we're working really hard, so you need to adapt. And it does this by increasing, anti-inflammatory genes or antioxidant genes. But in the brain, it increases a very important one called brain-derived neurotrophic factor. And this is basically one of the best things that you could do for your brain. Brain-derived neurotrophic factor is a growth factor that causes you to grow more brain cells. It causes the connections between synapses to get stronger, so it's involved in learning and memory. It's essentially a youth elixir for the brain, and lactate's involved in making or signaling to your brain to make more of it. So vigorous intensity exercise is great for that reason, but it's also great because it is a way of improving our cardiorespiratory fitness, our cardiovascular health. And so cardiorespiratory fitness is a measure of, it's usually measured in terms of VO2 Max, as you know, and it's the maximal amount of oxygen that you can take in during maximal exercise. And cardiorespiratory fitness is really a marker. I personally think it's now, emerging data over the last 5 years or so has proven that is probably the strongest marker we have of longevity today. There's a lot of people out there looking at X, Y, Z biomarker, your epigenetic age, lots of different aging clocks or your blood glucose levels, lots of different things that you can look at. But it turns out that cardiorespiratory fitness really is the prominent marker for longevity. So if you're someone that's doing endurance exercise, like if you're an elite athlete, these people are training 30 hours a week?
Yeah, on average.
On average.
Yeah.
For the majority of people that are really just sort of interested in health and fitness and perhaps, don't have a lot of time to work out a lot, they're barely trying to meet the minimum requirement of 2.5 hours a week of moderate intensity exercise, let's say. They're limited by time constraints, let's say, but they want to improve their VO2 max. They want to improve their cardiorespiratory fitness. So what kind of exercise do they engage in to improve their cardiorespiratory fitness? So if you're doing something like 30 hours a week, that is something that's, you're splitting your time between doing cardiovascular endurance training, but also some high intensity interval training. You're doing some vigorous intensity exercise along with that as well. So you're kind of covering all the bases. But for people that are not doing such long hours of training, there have been studies that have shown that even people that are meeting the 2.5 hours of moderate intensity exercise, per week, if they're only doing this sort of zone 2 training, where they're not really going into that vigorous zone, up to 40% of people have a hard time improving their VO2 max. Mm-hmm. And they're called non-responders. And so why is that? Why are they not responding to, cardiovascular, just simple endurance training, 70% max heart rate, let's say, or below? So about moderate intensity exercise. And it's not really known why, but it's thought that the stress isn't great enough to cause the adaptations to allow them to improve their VO2 max. And so when you take those non-responders and then have them engage in vigorous intensity exercise, then they're able to improve their cardiorespiratory fitness. Again, coming down to that adaptation where you're putting a greater stress on the cardiovascular system, and therefore your body is responding to that stress with a variety of different beneficial, response pathways. And so VO2 max, I would say, again, as a marker of longevity, one of the best ways you can improve that is by engaging in vigorous intensity exercise. Mm-hmm. So that would be kind of the long-winded answer to the different types of, endurance versus kind of more vigorous intensity exercise, and why I think there's differences, but also, there's some overlap as well. So, there's a lot of other aspects I'm not getting into.
There's so many sort of vectors at play here. There's aerobic capacity, anaerobic capacity, the two different kind of energy systems and what they do for us. There's the time constraint aspect of this. How do you get the most bang for your buck, especially if the variable you're trying to move the needle on is VO2 max? The more time crunched you are, the more important that becomes to prioritize. There's brain health. There's cardiovascular health. There's all of these sort of, things to tease out. What's interesting though is, I'm of the age where I grew up thinking that lactate, was this waste product that you're always trying to, get rid of, and fitness was about your capacity to flush it effectively so that you could kind of rebound and recover more quickly. But to learn through your work that this is actually this signaling molecule that it plays an important role in all these different kind of pathways in the body is a super fascinating thing. So maybe let's start with brain health and go a little bit deeper on what you were talking about with respect to brain-derived neurotropic factor and what this is doing. So when we're building up lactate as a result of vigorous exercise, it's passing through the blood-brain barrier. It's going into our brains, and it's doing all sorts of beneficial things like something called neurogenesis, right? So talk a little bit more in depth about the importance of lactate or the relationship between it and the healthy brain that we all are trying to, kind of foster.
Yeah, I would love to. It's one of the reasons why I really try to engage in a lot of vigorous intensity exercise. That I've got neurodegenerative disease on both sides of my family. So for me, I'm very brain focused when it comes to exercise. It's one of the main reasons I do exercise. I feel better, but I also know that I'm delaying the aging of my brain and helping prevent neurodegenerative disorders. So lactate, it depends on there's a lot of factors at play in terms of how much lactate you're going to make, right? So how intense you're going in terms of your exercise, your mitochondrial function, a lot of individual variability here at play. But generally speaking, when you start to go into that vigorous intensity zone, you can start typically our steady state lactate levels are like less than 1 millimolar. And when you start to go into, 80, 85%, 90% max heart rate, you can get anywhere between 7 to 14 millimolar of lactate in your bloodstream. And this can be measured. You can go out and get tests. I've measured it before for myself. The lactate levels don't last long in your blood system. And that is because it is being transported and going and taken up by other tissues. So really, as far as I've measured repeatedly, it's about 20, 25 minutes, and then it goes back to your baseline. So there have been a variety of studies that have shown, by the way, Dr. George Brooks from UC Berkeley was the first to really propose at the time this lactate shuttle theory, as he called it. And it's not really a theory anymore. It's been proven time and time again. But he was really the first to propose that lactate was being transported into circulation. It was being taken up by a variety of other tissues, notably the brain, and that it was, having beneficial effects in these other organs. So, in the brain, so there is a transporter. Lactate goes through this, it's called an MCT transporter, and it gets into the brain. And there's been a variety of human studies showing that actually during physical activity, lactate is fueling the brain because, your brain is working hard. Your heart is working hard during exercise. Your lungs are working hard. Your brain is also working hard, right? I mean, this as an endurance athlete. Your brain is also working hard during exercise. And lactate's fueling that, fueling the brain activity. That's been shown. And some of that also has to do with the fact that lactate, it's increasing brain-derived neurotrophic factor. So you mentioned that, BDNF for short. And that is doing a lot of things. It is helping grow new neurons, particularly in a part of the brain called the hippocampus, which is involved in learning and memory. It's also a part of the brain that atrophies with Alzheimer's disease. So there have been a variety of studies that have shown even older adults that are engaging in moderate intensity activity for about a year can increase the size of their hippocampus by like 2%,
Wow.
which is amazing because typically older adults lose their hippocampus atrophies with time. So not only were they fighting and staving off the atrophying, but they were also increasing it. So that was pretty, I think, one of the big eye-opening studies. And this was over 10 years ago. This was like a 2012 study that was published showing this. So the brain-derived neurotrophic factor is growing new neurons, can increase the size of the hippocampus, but also it's really important for something called neuroplasticity. And that is, it's kind of like you can think about keeping our brains more pliable and malleable and adaptable. So really, neuroplasticity allows our brains to adapt to a changing environment. And this is important for aging, but it's also important for mental health. So people with major depressive disorder, for example, they have dysfunction in neuroplasticity. So, and that kind of makes sense, right? If you can't adapt to a changing environment, it's very stressful and can cause anxiety. It can be depressing. So there have been a variety of different, researchers that are trying to target neuroplasticity as a treatment for depression. So neuroplasticity not only plays a role in brain aging, but it also plays a role in mental health. And I think that's important to point out because, I think almost everyone by now knows that exercise is one of the best things you can do for mental health, right? It's just, you can't deny it, right? You go out, even doing like a 10-minute high intensity workout, you feel better, you feel better.
Sure, but that's downstream of all kinds of other things that are happening, right? The hormonal regulation aspect of it. How important is the plasticity piece in the mental health conversation? And, what is the significance of that plasticity increase as a result of vigorous exercise?
Yeah, it's a good thing that you point out. I think there are a lot of things that are changing with exercise. Endorphins that make you feel good, endocannabinoids that make you feel good. There's serotonin gets increased, right? So there's a lot of different, I would say, short-term effects for that are potentially responsible for the beneficial elevation in mood that you experience after exercise. With neuroplasticity, I would argue there's more of a long-term effect, right? It's your brain is now able to adapt better to a changing environment, and that's going to have more of a long-term consequence. So neuroplasticity is another really important thing that brain-derived neurotrophic factor regulates. And again, coming back to the lactate, which is what we were talking about, lactate is also, when I say it's a signaling molecule, it is communicating and activating a lot of different things in the brain. So norepinephrine is another one that's been shown to increase. And norepinephrine is a neurotransmitter that is responsible for focus, attention, but also mood. Mm-hmm. So people are often treated with norepinephrine reuptake inhibitors for anxiety and also depression. So lactate plays a role in increasing that as well. But again, we're just getting down into the nitty-gritty of one aspect of exercise. And as you pointed out, there's a whole plethora of changes that occur with exercise that are beneficial, not limited to lactate. I think the lactate story is so important because it really is a proven mechanism in both human and animal studies. It's something that's measurable. Again, it's something also that we've known it links the more high intensity exercise, the more vigorous exercise with, a lot of these beneficial effects on the brain.
Mm-hmm. What do we know or don't know yet about the impact of lactate or just vigorous exercise in general on the impact of somebody who is suffering some form of neurodegeneration? Like, obviously, it's a good thing, and I'm sure it ameliorates the symptoms. Is there any indicia of it reversing any of those conditions, or is it purely something that is preventative and perhaps helpful in terms of like managing somebody who's in that state of decline?
I would love to see studies like that done. It's a really good question, Rich. I will say this. So I haven't really seen much with respect to someone that has neurodegenerative disease, for example, and let's say you give them sodium lactate, right? So that's something that you can administer and see how that affects their cognition. What has been done is studies looking at traumatic brain injury. So traumatic brain injury in many respects, I think, is almost like studying brain aging in real time because you're having this traumatic effect on the brain, right? So whether it's a blunt force or you're in a car accident or whatever, and it's causing just massive inflammation, massive oxidative stress, and a lot of the pathological features of, for example, Alzheimer's disease happen with traumatic brain injury, like amyloid beta plaque buildup. It happens, boom, like that after a traumatic brain injury. So traumatic brain injury, like I said, in many ways, I do think is kind of like almost like a model to study brain aging or neurodegenerative disease in sort of like this real time where you get like a young person and this, terrible thing happens, and then you can kind of study it. So there have been studies looking at traumatic brain injury and administering sodium lactate, and that has been shown to improve some of what are called the Glasgow scores. So these are like scores that are done to look at how people are improving in terms of their traumatic brain injury or responding to treatments. And so those studies have found that sodium lactate, for example, can improve Glasgow scores with respect to the traumatic brain injury, which to me indicates, and there's a variety of different tests, a battery of tests that are done. I don't know all of them, but in general, it seems as though the sodium lactate is improving those scores. And I'll tell you, it makes a lot of sense to me because, first of all, I don't know that many people realize this, but our neurons actually consume a lot of lactate for energy. In fact, they prefer it over glucose. And that's because our astrocytes, which are supporting brain cells in our brain, produce lactate. So our astrocytes are mostly glycolytic. So they're not using their mitochondria. They're using glucose and they're producing lactate. And then our neurons are taking up that lactate and they're using it as energy, again, because it's energetically favorable. So if you give someone with traumatic brain injury, or perhaps I would go as far as to extrapolate Alzheimer's disease, if lactate is getting into their brain, it is less energy to use that lactate than it is to use glucose. And on top of that, there's something called the glucose sparing effect. So glucose, if your neurons don't need to use glucose, if they're using lactate instead, this allows glucose to be spared. And why is that important? It's important because glucose is used to make something called NADPH, which is a precursor to form glutathione, which is the brain's major antioxidant system. And this is why I think that sodium lactate helps with traumatic brain injury. And it's why I think that lactate in general is good for the brain and could help with, neurodegenerative diseases in general, is because, when you're freeing up the glucose, it's now used to make this important antioxidant in the brain. And so you're getting a couple of things happening here, like a 2-punch hit, right? You got the lactate, which is energetically favorable. It's being used by neurons to make energy. They like using lactate and they prefer it. They're using it when the astrocytes are functioning normally. TBIs mess that up. So under a TBI condition, your astrocytes aren't making the lactate. And so everything's all messed up. So that's number one. Number two, now you're sparing the glucose. And the glucose can be used to make glutathione. And it's hands down, glutathione is so important for the brain, particularly under conditions of TBI or neurodegenerative disease, brain aging in general.
How does that work in terms of how your body prioritizes, the sort of byproducts of glucose? Because if you're generating your own lactate, it means you're burning your glucose pretty quickly, right? Like it's a match that burns out fast if you're staying in that state. So while you're burning this glucose, I suppose that is also doing this other. The second punch of the 2-punch. Is that what you're saying?
It's a good question. So you're, obviously like glucose is important to get into the brain, and the glucose is being used by your muscles at the same time if you're exercising.
Those are gobbling it up. And, and that's like getting in the way of it getting to your brain.
Well, you have to fuel your body.
Which makes me think is there, in the way that exogenous ketones are like all the rage, is there a version of that for lactate, an exogenous lactate, to create this sort of like brain fuel, so that even when you're not in that state of generating your own lactate, you can be feeding it to your brain in a way that has all of these other benefits as a consequence?
So I don't know that I've seen that version, like a sort of like lactate kind of ketone.
Right. Drink this and your whole body will burn, but it's good for your brain. Is that what it would feel like if you injected it into your veins? It would, right?
Well, you're funny. It's funny because you're thinking about it in the right way, because beta hydroxybutyrate, right? So that is like the major circulating ketone when you're in ketosis, or if you're getting one of these exogenous ketone drinks, which they use beta hydroxybutyrate. It has very similar properties to lactate. It increases brain-derived it's a signaling molecule. It increases brain-derived neurotrophic factor. It also can spare glucose, so it can be used as an energetically favorable source of energy by the brain under traumatic brain injury conditions. And some of those studies have been done. In fact, lactate and beta hydroxybutyrate also almost do very, very similar things. And it does that glucose sparing effect as well. So it's sparing the glucose in the brain, allowing it to be freed up to make glutathione. So it's so interesting that you bring that up, because in a lot of ways, they're almost very, very similar in terms of what they can do with their respects as being a signaling molecule in the brain. So so it's kind of interesting.
Here you go, Rhonda. Like, I'm serving you up like this is a whole new market. You could create this product and turn it into a whole thing.
Or you could just work out and not only.
But everybody loves I don't have to work out. I can get the benefits of it. But I'm taking that thing.
No,
people love that.
I know people do love it. Yeah. I mean, who doesn't? There's every year you'll find a study
for every diatribe about why exercise is important is a way to identify some end run around it that
I just don't think you can shortcut it like that. Now if you're having TBI or you're an Alzheimer's patient, there's an argument to be made to give them some kind of elixir that they can that can benefit them. But if you're like us, there's an argument to put in the effort, right? Because, it's not just about lactate. Lactate's one part of the story. There's cardiorespiratory fitness, as we mentioned, right? Mm-hmm. And that's another important marker for longevity. And there's also studies showing that, you can take a 50-year-old person who is sedentary, So they're not physically active, but they don't have any other markers of disease. So they're not, they don't have type 2 diabetes or cardiovascular disease or hypertension. And put them under a pretty intense exercise protocol for 2 years. And basically, you can reverse the aging of their heart by almost 20 years. So this study was done by Dr. Ben Levine out of UT Southwestern in Dallas. And what he showed was, so as we age, our heart structure it changes with time. So our heart gets stiffer and shrinks. And that plays a role in increasing our cardiovascular disease risk. It plays a role in, affecting our aerobic capacity. So what he wanted to know, he asked the question, can I take these people that are essentially been sedentary their whole life, but they're otherwise not, they don't have any identifiable diseases, and can I make their hearts look better? And so his group put them on a pretty intense exercise protocol for 2 years, and it was a progressive loading. So, it wasn't like right out the gate they were doing 5 hours of exercise a week, which is essentially what they were doing at the end of the 2 years. They're doing about 5 to 6 hours of a lot of vigorous intensity exercise, moderate as well, but they were doing high intensity interval training. They were doing something called the Norwegian 4x4 protocol. This is, you're doing 4 minutes of as hard as you can maintain for that 4 minutes. So, most people are probably doing 80% their max heart rate or something like that, or they're not going all out, obviously. And then you recover for 3 minutes, and you're really going down to let your heart rate go down. And then you do that 4 times. They did that once a week on top of just doing a lot of aerobic, training. And they were able to reverse the structural changes to their aging heart by 20 years, wow, which is incredible. Absolutely incredible. You take a 50-year-old and make their hearts look like a 30-year-old. Like who wouldn't sign up for that? You're not going to get that with beta hydroxybutyrate or lactate. Yeah.
And what do we know? Again, another what do we know or not know about the impact of vigorous exercise versus endurance exercise on moving the needle on cardiovascular health?
I mean, they're both good for cardiovascular health, right? What I was mentioning was the cardiorespiratory fitness aspect. And the reason I was mentioning that is because almost half the population isn't responding to that if they're just doing the sort of moderate intensity exercise where they're doing 70% their max heart rate for 2.5 hours a week. I like to mention that because it seems as a sizable part of the population really does need a little bit more stress for their body to adapt for whatever reason. Mm-hmm. I don't know that that's well understood, but what is understood of that is, does it occur? And so, I do think, again, you don't want to compare apples to oranges. So a lot of times we'll look at what these endurance athletes are doing, and they're doing a lot of zone 2 exercise, right? But they're doing a lot of it. So I don't think you can compare someone who's doing over 10 hours a week to two.
I mean, nobody should really look at that as a benchmark to decide what they're going to do. And, those people, their zone 2 is very unlike the average person's zone 2 because they've been doing it for so many years and they've built this huge base. Their kind of pace that they're able to maintain would be, beyond the threshold of an average person. So they're putting even though they're cardiovascularly, they can handle it. They are putting an additional strain on their ligaments and their muscles and things like that. That's very different from the average person. But in that conversation, I think it needs to be said that what endurance athletes or any elite athlete understands is the idea of training on these polarities. And I think the average person spends most of their time somewhere kind of in the middle. They're going a little bit too hard for zone 2. If they only have a couple hours a week, zone 2, because they're not that fit, feels like they're not getting anything out of it. And they're not pushing themselves hard enough to get into that threshold vigorous state required to catalyze all of these kind of benefits that you're talking about. So a lot of it is slowing down and then knowing when to speed up and how you create that mix and the construct of how many hours a week you're capable of devoting to these things.
Right. And then don't forget, we have to add in some strength training and resistance training. Right. So, I mean, there's a lot, and then you have to work and take care of your family. And so, there's a lot of factors here. And I think that's where I personally do like I guess, option to go a little bit harder and not have to spend as much time, and at least be able to make improvements to my cardiovascular system, to cardiorespiratory fitness, and get things like the lactate, and not to mention there's other benefits, like you're increasing the number of mitochondria in your muscle. It's called mitochondrial biogenesis, and that's both doing moderate intensity and high intensity. Exercise does that.
But over time, isn't zone 2 a more effective way to build mitochondrial density?
So it depends. If you're comparing, let's say you're comparing someone that is doing a 30-minute zone 2 run versus a 30-minute more vigorous run, then you're gonna increase the number of mitochondrial density more by doing the vigorous intensity. And that is because lactate itself actually signals to your mitochondria to make more mitochondria. And the reason for that is because your body, it's an adaptation. Your body is freaking out. Your body's going, I can't use my mitochondria. I'm not getting oxygen here quick enough to make energy with my mitochondria. Therefore, I need to make more mitochondria to try to adapt so that I can use the mitochondria to make the energy. Do you see what I'm saying?
Yeah.
So the high intensity, so the vigorous intensity exercise stresses the mitochondria in a way through lactate that's increasing the mitochondrial number. But zone 2 training can affect mitochondrial size. So it can increase the mitochondrial size. And so there are differences there. But generally speaking, if you were doing the same volume of training, then a more vigorous exercise would actually improve mitochondrial density more. Now, if you were to then take and do, like, let's say you were going to do an hour-long zone 2 versus, the 30-minute, then maybe you start to get more differences, right? So again, it's like it all depends on what we're comparing here. Apples to oranges, like, are the same durations the same? Or because most of the time, if you're doing zone 2, you're going to have a longer duration anyways, right? Then that's the whole point of doing high intensity interval training is it's time efficient, right? So you can get more bang for your buck in some regards. Now, there are differences as well. And certainly for people that are endurance athletes, they have to spend more time doing more zone 2. But in no way would I ever say or think it's accurate to say that doing vigorous intensity exercise is not improving your mitochondrial function or improving mitochondrial number or density, because it absolutely is. It's very, very strongly improving mitochondrial function and mitochondrial density. So I wouldn't feel like you're lacking something by engaging more in high intensity interval training and not doing enough zone 2 either. So I think there's a little confusion out there with that. So just want to clarify that.
We're brought to you today by Bonn, which is this really cool company that makes a fantastic broad line of evidence-based holistic wellness products. They make everything from blue blocking glasses to red light therapy devices to EMF shielding products and tons more. Are you ready to elevate your wellness journey? Of course you are. So go to bonncharge.com/richroll. Use code RICHROLL at checkout for 15% off their entire range of wellness tools.
So Squarespace has been a long-time partner of the show, and what I love about it is it just demystifies everything about what's required to make a website. You don't need to be a designer. You don't need to know how to code. Everything is right at your fingertips. They make it super simple. And they've got these unbelievably beautiful templates to choose from that are oriented around whatever your needs may be.
Whether you need a simple landing page or a full-on online shop, Snap, Crackle, Pop, Squarespace has the tools you need to launch your business, including e-commerce templates and inventory management. So make that website. You got it. Click the link in the description below for a free trial. And when you're ready to launch, use offer code RICHROLL to save 10% off your first purchase of a website or domain.
Let's turn to the metabolic health aspects of this. When you think of endurance training or zone 2, you're thinking about the efficiency with which your body is able to utilize oxygen and the adaptation to burning fat as fuel. That's sort of like the thing that you're trying to improve when you're doing that form of exercise. Whereas high intensity exercise, you're burning glucose, for fuel. You don't have the ability to store glucose like you can fat. So you're going to run out of that eventually. And all the lactate happens and all of the like. What have you sort of unearthed in terms of the impact of these two different types of exercise on metabolic health and maintaining like sort of our ability to regulate our metabolism optimally?
Yeah. So I think that was a very nice way to put the question. I mean, you explained a lot there. And so just to clarify, I do think that, so when you are doing more vigorous intensity exercise, first of all, it's not just an all or nothing, 0 to 1. You're not just only anaerobic. I mean, unless you're really
and
all
of
out
these things
sprint.
are on a spectrum anyway.
Right.
Yeah.
So I think some people people like to think black and white, as we know. And so I do want people to realize that when you're doing like a vigorous intensity type of exercise that is, let's say 80, 85% max heart rate, you are also using your mitochondria and you're also still burning fat and you're doing that as well. So you're shifting and doing both. It's not just one or the other. And unless you're really doing like a Wingate or something like all out sprint, right? Where you're going I've never done one. So I don't really know how it feels. I've tried to go all out. I don't know that I've actually have, but it's pretty terrible.
There's still fitness to be found for you then.
Hill sprints are like the bane of my existence. They're so hard. But so yeah, I just wanted to mention that, and also that because when you're doing high intensity interval training, vigorous exercise, you are increasing mitochondrial density, which again, the more mitochondria you have, you do get better at burning fat as well, just by having more mitochondria. But as you said, yes, so people that are doing more type of zone 2 training do become better at burning fat because they're kind of like staying within that threshold of not going into burning glucose, right? And so it does kind of give an advantage for that reason. But it's not that doing the other type of exercise isn't getting you that at all, right? That's just important to consider. But the other metabolic effects that I think are also important, and again, not black and white, is that if you are doing more of a vigorous type of exercise, going again to lactate being a signaling molecule, lactate signals to your muscle to get more glucose in it, right? Because your muscles are using so much glucose that your body's going, I got to get more of this in here so that I can keep making energy. And so what it does is it increases the production. It's actually what it does. It increases the translocation of what are called glucose-4 transporters, GLUT4 transporters, which are just below the surface of the muscle. And lactate causes them to go up to the cell surface and kind of, it opens up the floodgates for glucose to come in, right? And this is really, really beneficial because it is a way of getting glucose out of your circulation, bringing it to your muscle where you want it, right? So the elevations in your GLUT4 transporters last for like 48 hours. And it's why there have been studies that have come out recently showing that you can do 10 bodyweight squats, every 45 minutes throughout about 8-hour workday. And that'll improve your blood glucose regulation better than a 30-minute walk.
Wow.
And I timed
myself. Is that why you were just doing those before we started the podcast?
I was doing it for the brain.
Yeah, okay.
But again, so the more vigorous the intensity of the exercise, the more improved glucose regulation you are going to have. And that is absolutely time and time again proven. So you will improve your glucose regulation by doing more vigorous types of exercise, again, through lactate, which is that signaling molecule. And it's really important to realize, we talked about the heart, the aging heart, how it gets stiffer and smaller with age. Well, the stiffness of the heart is actually partly caused by glucose in the vascular system. So the longer you have glucose sitting around in your vascular system, it reacts with proteins, it reacts with DNA, lipids, but specifically it reacts with proteins, including collagen. And through what's called the Maillard reaction, it forms something called advanced glycation end products, or AGEs for short. And these things, they basically cause your proteins to become stiff. And they last. Like if you're talking about collagen in your vascular system or in your myocardium, for example, your pericardium has collagen. It gets stiffer as these advanced glycation end products form, and it's all a byproduct of glucose being around for too long. So people with type 2 diabetes, for example, have problems, stiffness of the blood vessels. They get cardiovascular disease sooner, all sorts of problems, and so I think one of the reasons that exercise plays an important role in de-stiffening the heart or preventing the stiffness of the heart is because of the just enormous improvement in glucose regulation that you're getting from exercise. And it's not that you're not getting glucose improvements from doing like zone 2. You absolutely are, for sure. Especially like now, if you're comparing again 20 minutes to 20 minutes, you're going to get better glucose regulation with more vigorous intensity exercise. But generally speaking, any type of cardiovascular exercise is going to improve glucose regulation. However, the more vigorous the intensity, the better the improvement, and that is because lactate is the signal that's increasing those glucose transporters to come up to your muscle and bring in more glucose.
I'm trying to understand the distinction between taking that glucose that's sitting around and putting it to work, and the impact that has on not stiffening up the heart as you described, because you're deploying it, you're making use of it, right? But your ability to regulate glucose is a different thing, right? Like those are two different things. So what is glucose regulation, that gets modulated or improved as a result of the high intensity exercise?
I mean,
that doesn't happen with endurance or strength training.
I don't know that there is something that doesn't happen with other endurance training. I just think it's a more robust effect, if that makes more sense. And there's a lot of different things that are happening, but I'd say one of the main things is the disposal of glucose, getting rid of it, right? And that's going into muscle rather than adipose tissue, where when it's stored in adipose tissue, that's not a good thing either, right? So you want it to go to your muscle. And so really the regulatory role I'm talking about here is like disposal, like getting rid of it through muscle, right? So it's not sitting around in your vascular system for a longer period of time. But there's so many different aspects of glucose regulation.
Right. I guess what I'm getting at is more like, okay, so you're making use of it. You're putting it to work. You have these receptors on the cells that are able to kind of take the glucose in. But on some level, like metabolic health or glucose regulation is a function of pancreatic health, right? Like how sensitive are you to insulin, and how functional is that aspect of metabolic health kind of like working? So does exercise have an impact on the insulin sensitivity aspect of it as well?
Yes. It's affecting so many different areas of, insulin sensitivity, glucose regulation with respect to the transporters, bringing it into muscle. There's a lot of different things that are going on with exercise. Again, it's not like this one thing only. It's many, many things. But the transport, getting that glucose into muscle is it's like a sink. It's a big reason why exercise does improve, your blood glucose levels in general, right? It lowers the long-term marker of glucose, HbA1c. But the thing about HbA1c is, it's a long-term marker of blood glucose. It's, 120 days or so, I think is what it is. It's how long your blood cells turn over. But you have to realize, the collagen that's inside of your vascular system that's lining your myocardium and your pericardium, like that's there forever, right? And so when you have glucose reacting with that collagen, we're talking about a long-term effect that's forever. It's contributing to the chronic, insidious type of stiffening of the collagen surrounding your heart and also in your vascular system. So it's playing a role in hypertension, but also in the stiffening of the heart, through the myocardium and pericardium.
Right. Interesting.
Yeah, it is. It really is, I think, one of the big reasons why exercise is so important for cardiovascular health also comes down to basically just glucose disposal, getting that glucose out of your vascular system. There's another thing I wanted to mention that comes down to sleep. And, not getting enough sleep also changes a lot of the glucose regulatory system, including insulin sensitivity, including glucose disposal. So going, all those things we just talked about. And what's interesting is that doing high-intensity interval training can really ameliorate most of those negative effects from not getting enough sleep in terms of like glucose and how it's like your glucose isn't being regulated. And that's something that I learned firsthand by wearing a continuous glucose monitor while I was a new mom and not getting sleep. The first year I was a new mom, I mean, it was like I was appalled by what was happening to my glucose. Like the first month, I would say, when I wasn't exercising, it was like in a cave, and my blood glucose levels were looking pre-diabetic. I mean, it was like really crazy because I was eating healthy. I wasn't eating a bunch of processed foods. I wasn't eating a lot of highly refined sugars or anything like that. And that's what sort of instigated me to sort of look into the literature and go, what is going on? If you're getting, fragmented sleep, how is it causing diabetes? And sure enough, there's study after study after study. I mean, just endless data out there showing that it does. And then I came across some studies. What I started to do was a spin class and noticed that it was totally better. Like it lasted about 48 hours, so I'd have to do a spin class like every 48 hours.
The poor sleep remaining constant.
The poor sleep was constant. Yeah. I mean, you have to feed your baby.
A mom with a baby.
Yeah.
Yeah.
But the high intensity interval training,
buffered it.
It really
basically.
buffered it. It really did buffer it. And then, sure enough, you look in the literature and there's, a few studies showing the same thing. And I do think it comes down to that. Again, it's increasing those glucose transporters, which are just, when you have a really high density of those on your muscle, it's like just having the sink open. So the blood glucose goes into your, vascular system and the sink's there and it just goes into it. And it's pretty sensitive for, like I said, about 48 hours. The first 24 hours are the most sensitive, but it's very important. It's very important. Exercise is important to do, even when you're not feeling like it is the bottom line.
My experience wearing a constant continuous glucose monitor was similar. Like when I don't sleep well, I my levels are all over the place. Like it's crazy and it's immediate. Like you suddenly like are a different person in terms of your body's ability to manage what you're putting into your mouth. It's crazy. But I'm curious before we kind of move on to the next topic or aspect of fitness, if somebody is extremely metabolically dysregulated, they have type 2 diabetes or they're pre-diabetic. What do we know about the impact of exercise, in particular vigorous exercise, on not just managing that condition, but reversing it? Like if somebody's in full-blown type 2, can they move that backwards? And if so, like how much?
Yeah. Great question. So I'll start with prediabetes because I love talking about this study. There was probably one of the largest studies done looking at the effect of exercise versus metformin on the progression of prediabetes into diabetes. And the reason I like this study is because there's so many people on metformin. I mean, it's a pretty common. You talk to someone with type 2 diabetes and they're on, some generic
form.
Now
it's a longevity drug. Like people that are perfectly healthy are taking it.
Yeah. And I disagree with that. But yes. So then this is why I like talking about this study, because exercise outperformed, and this was, people were doing like moderate intensity exercise, but it outperformed metformin by almost like 30 to 40%, maybe it was like closer to 40%. So, it outperformed it. In other words, it stopped the progression of prediabetes to type 2 diabetes much, much better than metformin did. Exercise, right? So I like that study because it really shows the power of exercise and how, no, you're not going to pill it up. You're not going to pill it up. It's not the same. There are, of course, a lot of other studies that have shown that people that have type 2 diabetes can reverse their type 2 diabetes with exercise. I don't know by the magnitude because, it's been so many years since I've looked at any of those studies. It's not something I've looked at recently. But I do think it is a powerful tool that we all have at our disposal that we should be using. And I'm saying I personally don't have type 2 diabetes, but like we as people, right? I mean, people with type 2 diabetes that think that they're sort of, cursed with this disease that they can never escape, it's not necessarily true. There are lifestyle modifications, including exercise probably being the most important. Mm-hmm. I don't think that anything is more important than exercise in terms of health, but also in reversing type 2 diabetes. I think that's one of the biggest factors. And again, the more vigorous the intensity, it is better. Like, so for example, there's been studies that have shown, if you take people that walk at a brisk walk, and then you take those brisk walkers and then make them do intervals where they're really going fast, and then brisk walking again, and then really going like almost jogging and then brisk walking. They again have improved markers of insulin sensitivity, of glucose regulation, all those things if they're doing the intervals, right? Mm-hmm. So vigorous exercise is really important with respect to, I would say, preventing the progression of diabetes, protecting you against getting diabetes, and also in terms of helping reverse type 2 diabetes, all of the above. Very, very important.
Yeah. When you think about what people suffer from the most, it's, being metabolically dysregulated, pre-diabetic, diabetic, it's cardiovascular disease, it's stroke, which is just a circulatory, condition, disease, right? And hypertension, like high blood pressure. So high blood pressure, obviously exercise is going to lower your blood pressure. Are there things about that aspect of this that are worth kind of highlighting?
With respect to comparing
like a sedentary person and their risk, who is sort of teetering on hypertension, and what exercise can do to move the needle on that.
Yes. Yeah. There's been quite a few studies. There's one in particular, I think it was a meta-analysis of multiple different randomized controlled trials showing that it was like 30 minutes a day or something. Don't quote me on this. Maybe about 30 minutes, 3 times a week, I think. And it was moderate to vigorous intensity exercise. Again, I think it was about 3 times a week over the course of, a month or so. These people had improvements in their blood pressure that were comparable to antihypertensive treatments and antihypertensive drugs. So yeah, it can have druggable size effects, if you are committed to improving your health, improving your blood pressure, without taking medication. You have to be committed to it. It's not going to happen unless you put in the effort. But if you're willing to go 3 times a week, do 30 minutes of, 80% max heart rate, let's say, then studies have shown that can have an effect on your blood pressure that's comparable to taking an antihypertensive drug. And I think that's profound, when you're talking about druggable size effects here. And it's not just hypertension that's been shown, depression as well. It's been compared to a lot of different SSRIs. So there have been studies that have compared like running to people taking SSRIs, and it was as good, if not better, at improving a variety of depressive symptoms in people with depression. Running was compared to SSRIs. So now
it's wild.
It is. It's some people have like depression where they just can't even like get out of bed and do that run. That's like a whole other, category. But there are people that have depressive symptoms. Maybe they don't have full-blown like major depressive disorder, but they have anxiety or bouts of depression, or and they can move, like they can get enough willpower too. And so it's really important. It's such an amazing tool that we have to improve so many aspects of our health. I did a lot of research in nutrition, and so it's something that I've always thought as the most important thing. And I'm not saying I don't think nutrition is important, but I think exercise is the most. I think it's the most important thing.
It seems to be the consensus.
Yeah. I think, you can
across the board, and in particular with respect to health span extension.
Right.
Yeah.
And just even all-cause mortality. I think you can get away with some other bad behaviors, like I said, like the sleep. If you're not getting enough good sleep, there's also studies showing that people that are getting fewer than 7 hours of sleep a night, they have a higher all-cause mortality than people that are getting greater than 7, like 7 to 9 hours a night. But if they're physically active and getting fewer than 7 hours, guess what? They have the same all-cause mortality. Again, so exercise, I think, really does forgive some of the sins. And that's where, if you're going to cheat, make sure you're physically active.
But they do say you can't exercise your way out of a bad diet, which makes me think about elevated cholesterol. So if somebody has a high ApoB or their LDL is out of whack, maybe they're on a statin or their doctor has told them they should be. What is the impact of exercise versus making changes in your diet to deal with that specific thing?
Yeah, you're absolutely right. Dietary changes for ApoB, LDL, that's a big one for sure. Because we know saturated fat, especially in combination with refined sugars, make a disaster for ApoB and also for small dense LDL particles, which kind of are more prone to lodging into the arterial wall. And so, yes, diet is important, and you can't exercise your way out of a bad diet in that regard. So you do need to care for both, for sure. But I do think, like, if someone held a gun to my head and said, choose one, what's the most important thing? I would say exercise.
Yeah. Cancer. What do we know about the impact of exercise on cancer prevention?
Cancer prevention and treatment. I mean, that's I think one of the, cancer. So we've been talking a lot about cardiovascular health. And as you mentioned, it's like the number one cause of death in the United States and a lot of, I think, most developed nations. Cancer is number 2 cause of death, right? Follows cardiovascular disease. And exercise is one of the best things you can do for cancer prevention and also for cancer treatment. In other words, like if you've been diagnosed with cancer, which is probably where most people wouldn't they wouldn't exercise. Mm-hmm. They think, oh my goodness, right. I need my energy. I need to rest. And in fact, I think a lot of oncologists for many, many years were advising against exercise because they didn't think they could. But as it turns out, exercise, when you exercise, so many different things are happening. So you're having inflammatory immune cell changes. So exercise can improve and increase the number of a type of immune cell that can kill cancer cells. So cytotoxic T lymphocytes is one of them. Natural killer T cells is another one. But also what you have to realize is that, cancer cells take a long time to form a tumor. If we're talking about solid tumors, so not blood cancers, right? Takes a long time to form a solid tumor. I mean, this is something that's like a decade. It doesn't just happen in a year. I mean, it takes multiple years before you're actually forming a solid tumor. And so as you get that 1 cancer cell, and then you get the 2, and then the 4, and then you get the 8, and whatever, as they start to divide, cancer cells are not like our normal cells. They're really wonky and messed up. They've got all sorts of abnormal things going on. They're what are called stressed cells. And it's one of the reasons why chemotherapy works is that, so chemotherapy is toxic, right? It kills normal cells too, but it kills cancer cells because cancer cells are, in a way, they're primed to die. They're waiting to die, but they've gotten mutations that have helped them override our natural programmed systems that are trying to kill them, or they evade the immune system, or they found ways around it, right, to die. And so they're kind of waiting to die, and they just need like a stressor to help push them over the edge, which is kind of what a chemo drug does, because chemo is toxic, and so it's that push. Mm-hmm. Well, exercise also is a stress. And so when you exercise, it is a stressful thing on your body, and you increase the production of inflammatory cytokines while you're exercising, but then you have this beneficial response, this adaptation of anti-inflammatory cytokines. So you have a net benefit of anti-inflammatory effect, for example. Well, when you're exercising, your normal cells are able to make antioxidants and anti-inflammatory cytokines, and they're adapting. Cancer cells can't adapt. And so exercise actually can cause them to die because they're so stressed. That's one thing that happens. And so it's one of the reasons that you can sort of, if you have a cancer cell or 2 or 10 or 20, the more you're exercising, the more you're likely causing your immune system to be able to find them by increasing those important immune cells I talked about that can help, kill cancer cells. The more you can kill them directly from just the stress. But also, the cancer cells have something on them called they have mechanoreceptors on them, which our normal cells have too. They sense movement, basically. And as you exercise, your blood flow is moving, right? And so, again, it's another type of stress that kills the cancer cell, but not normal cells. And these are usually cancer cells that are in your vascular system, right? So these are called circulating tumor cells. And so those are the ones that the blood flow itself, just the shearing force of it, can kill because the cancer cells can't take that shearing force stress. So that's a very interesting way that exercise can play a role in prevention and also cancer treatment. And there's been a variety of studies that have been done now looking at people that have colorectal cancer or breast cancer, and they engage in exercise. These people are like 40% less likely to have cancer recurrence and 63% less likely to have die from their cancer. So they're improving their overall cancer outcome, right, just from exercising. And also there's been studies showing that people that are exercising that have been diagnosed with colorectal cancer and breast cancer are the 2 cancers that have been looked at the most in this regard. But they decrease their number of circulating tumor cells, those cells that escape the primary site of the tumor, get into circulation to go take camp somewhere else, right? It's called metastasis, cancer metastasis. Well, if you can stop your cancer cells from metastasizing, that really improves your outcome as well. And exercise has been shown to do that. So again, it plays a big role in that as well. But then again, exercise, you talked about prevention. There's so many things going on with prevention, right? It's changing our immune system. It's improving metabolic health. Metabolic health is important for cancer as well. I mean, obesity is, there's like 13 different cancers that are associated with obesity, and everything from glucose and insulin to hormones. I mean, there's so many factors at play, that we could go on and on.
These things are not independent of
They're
each
not
other.
independent.
Yeah,
exactly.
They're all connected. It's all connected. It's interesting. I mean, it makes sense on one level, like everything that you said, like, of course we should be doing that. And I can understand why that would have a positive impact and in terms of like staving off the progression of cancer. But on the other hand, I'm thinking like exercise-induced stress creates oxidation, which, my layperson brain is like oxidation bad, right? Like this is not good for your cells and probably isn't good for cancer cells either. And the inflammation that is a consequence of exercise, also inflammation, bad. You don't want this. This is not good for your health, right? But there's differences between acute and chronic. And I don't know, maybe you can kind of like, if anyone else is struggling with this like me, you can kind of make that a little bit more clear.
Well, that's exactly right. And so exercise is a type of what is called hormetic stress, right? So this is a type of beneficial stress. It does create oxidation. It does create reactive oxygen species. It does create IL-6 and pro-inflammatory cytokines. It causes inflammation acutely. But there's an adaptive response to that. Our cells are creating antioxidant genes like glutathione, like superoxide dismutase, like all these other genes that are not only dealing with that little bit of acute oxidation that you just generated from the exercise, that little bit of inflammation that you just generated from the exercise. Not only is it dealing with that, it's dealing with the inflammation days later that's generated from just normal living, right? So it has a net anti-inflammatory and a net antioxidant effect. But as you mentioned, the cancer cells, they don't have that hormetic response. They don't have that adaptive response. They don't increase their antioxidant genes or their anti-inflammatory genes in response to the exercise. They can't. They are messed up. They are completely mutated and screwed up. And so they die. And that is the mechanism. That's the mechanism of how it works.
Yeah,
right.
Yeah,
and it's part of the reason why even, but Dr. Walter Longo, a mutual friend of ours, I mean, he's shown in a few studies now, what he coined is differential stress resistance. And he showed it in the context of fasting, which is also a stress on the body. And so the fasting itself, if you do that like shortly before cancer treatment, it also does a similar thing as exercise. It's differential stress resistance, right? It is killing the cancer cells almost selectively while causing the normal cells to have more antioxidant and more anti-inflammatory responses through that stress, that stress response that's happening, right? And so that's also the same thing with like deliberate heat exposure from the sauna. It does something similar, right? It acutely is like you get in the sauna, it's hot, you're creating reactive oxygen species, inflammation, IL-6 is going up, but the net effect is you have more what's called IL-10. That's an anti-inflammatory that's lasting for much longer than that acute inflammatory response. So a lot of these types of, beneficial types of stress, whether we're talking about exercise or fasting, or we're talking about deliberate heat exposure or even plant phytochemicals. So a lot of phytochemicals that are in plants like sulforaphane or resveratrol or curcumin and turmeric, these are all chemicals that are, they cause a little bit of stress in our body, but they dramatically activate stress response pathways like the NRF2 pathway, which is hugely beneficial in increasing a variety of anti-inflammatory genes and antioxidant genes. It's that good type of stress, the eustress that we're looking for, and that's exercise. That's something that exercise is doing.
Setting aside cancers of the blood, not all cancers are the same. There's some that are more resilient and some that are more kind of receptive to exercise in terms of like, what we're looking to do here?
It does seem like some of them are, and that's probably why a lot of cancers that are looked at are. So breast cancer, prostate cancer, like the ones that are like hormonal related to, and also very related to like metabolism in general, seem to be the ones that are really looked at in terms of being affected by exercise. And then colorectal cancer, colon cancer is another one that's been looked at a lot and seems to respond well to exercise. Now, I don't know about other cancers like brain cancer, for example. I would imagine it would be beneficial, but I think there's a lack of data to really to show that. But yes, cancers are different. You're right. I mean, so it's, I don't know that it's necessarily a sure thing, but I do feel strongly that, exercise is beneficial, like period. And it does seem to be beneficial for most types of cancer.
Hey everybody, today's episode is brought to you by Seed. Gut health. I talk about it all the time on the podcast. You know it's important. If you've even listened to a few of my podcasts, I think I've maybe devoted, a dozen, 2 dozen episodes to the microbiome. You got to take care of your gut health if you want to have optimal health. How do you do that? Well, your nutrition, your lifestyle habits, sleep, all of these things play into that. But it's also important to find a really good prebiotic and probiotic. How do you do that? Well, there's a lot of nonsense out there, so you got to follow the science. And the best evidence-based product that I found out there is Seed's DSO1 Daily Symbiotic. I've been taking it for, over 3 years at this point, every single day. There's just a tremendous amount of science behind this product. I urge you to check it out. And right now, it's a great time to do that because you can get 25% off your first month of Seed's DSO1 Daily Symbiotic. Hit the link in the description below to visit seed.com/richroll and use code RICHROLL25. Get on it. When it comes to health, sleep is a big deal, and there's just so much science out there to back up the role that it plays in every facet of well-being, from heart health to mental health, recovery, cognition, and just being able to show up as your best self. Getting a quality 8 hours per night is a personal non-negotiable that I go to great lengths to ensure. Now, I've tried many mattresses, but the one that's really won my heart is Birch, and there's many reasons for this, all of which boil down to the simple fact that Birch just does things right. In addition to being incredibly comfortable and cool, Birch mattresses are also firm in all the right places, and all their materials are sustainably sourced. Everything is hypoallergenic and toxin-free, meaning no harmful off-gassing typical of most mattresses. Birch is so confident in their product, they're offering both a 100-night risk-free trial as well as a 25-year warranty. Plus, they provide free delivery right to your door in a conveniently sized box up. And so I want to offer all of my listeners the chance to enjoy a deep and restful night's sleep with a new mattress from Birch. So right now you can get 27% off site-wide, plus 2 free EcoRest pillows with mattress purchase. Just go to birchliving.com/richroll.
What is the question around exercise that's nagging at you, and what would be the study that you would construct to get answers? Like, what's still out there that we don't fully understand that you wish we did, and have a sense of how we could if we could just do this one study?
Oh gosh.
It's probably a lot, right?
There is, yeah. I mean, I think, I'm really into the brain. There's been a variety of studies that I think we need to look at the impact of like lifelong exercise and neurodegenerative disease risk. And, and not in a way where it's just a questionnaire this 1 week, and then let's just say that's how much you exercise for the last, 10 years. Like, cause it's just not very good. It's not a very good indicator of, okay, whether or not they were actually exercising as much as they did that 1 week. Right? Because that's what a lot of observational data looks at. So I would love to see, something that is more like a randomized controlled trial, looking at people that are engaging in exercise or not, and their risk of neurodegenerative disease, particularly if they have genes that elevate their risk, like the ApoE4 allele is one that's a big one.
Yeah. To what extent does exercise override that genetic predisposition? If you take somebody who is a lifelong athlete and they're doing it perfectly their entire life and they have the right mix of endurance and strength and high intensity, does that create a situation in which they sidestep a disease that otherwise would have almost been a certainty?
And I think it would, for sure. I do, but we just don't have that data.
I want to move on to microplastics, but is there anything that we haven't kind of put a finer point on that you want to make sure that you make clear before we pivot?
Well, I didn't talk about my personal journey in strength training, but I will say that I've really gotten into
doing deadlifts
CrossFit,
and
squats, and I feel great. I feel I've gotten stronger. I feel really, really good. I got a coach I'm working with, and she's wonderful. She's helping me get stronger. And there's a lot of benefits to it. I think the muscle mass, and I know you've had Dr. Lane Norton on, who's talked a lot about the benefits. I won't go into all that. He's talked about that. But, I would say that in addition to the fact that I'm building up my muscle reserve, and that's very important for aging as well. It's hard. Like, it's really hard to do, like front squats and like to clean it up and do a front squat. And I find myself, as I start my day, I do my workout in the morning, and I find that it's almost mentally harder for me than physically. I mean, sure, it's physically hard, but it is mentally challenging for me to do what I'm doing, like the deadlifts and the squats, the cleaning and the squats. And I find that everything else in the day that I do is so much easier. And I love that. I love starting my day like that, because it's like I get through this like mental hurdle of this really hard thing in the morning. And then the other really hard work thing that I have to do isn't so hard.
Yeah.
Right. And that is it's just a whole other area of benefits I wasn't expecting at all.
That's really cool. I mean, I'm on a similar sort of trajectory as somebody who, I grew up as a swimmer, and swimming is, very much endurance focused, but it's all about intervals. So, from a very young age, you're doing, hard repeats with rest, and that's that whole world. So I kind of did that first, and then later in life became the ultra endurance athlete, and rarely, kind of exceeded my zone 2, and no gym work, and, almost none of that. Right. And now, I just turned 58, and it's like, oh, you need your muscle mass and all that. So I've never been a gym rat, but I've gone, into the gym with a level of intentionality that I never have before, to kind of explore this world that, I was never kind of really, that attracted to. But similarly, like, I'm not doing deadlifts and stuff like you are yet, I would say, because I've got a back issue that I got to resolve. But I do, I do agree. Like, I've seen those benefits in terms of what it feels like to be strong. Like, I know what it's like to be really lean and efficient and feel like you can just run forever. And this is a different feeling. I would say that I don't get the kind of endorphin boost that endurance exercise gives me. Strength is kind of it's kind of a dull. It's a good feeling afterwards, but it's different. It's a little bit of a duller feeling. But the one thing that you've now inspired me to go back to, which I haven't been doing very much of, is like high intensity stuff. It's like I'm either doing zone 2 or I'm doing lifting, right? But I'm not doing that other piece. And if anything was accomplished today, I'm now, kind of much more enthusiastic about making sure that I, tiptoe back into that as a core piece of what I'm doing every week.
Nice. Yeah. Mix in a little bit.
Yeah. Before we move on to microplastics, I think a good place to end this section of the podcast is to kind of explain specifically what vigorous exercise is, or high intensity training. Like, what would a routine be for somebody who's never done this before, or where can somebody find examples of routines to begin this journey?
Okay, so there's a lot of examples of what a high intensity interval routine would be, depending on like what kind of interval you're looking for, what kind of outcome you're trying to improve, whether that's improving your cardiorespiratory fitness, your VO2 max, or you wanting to really get that BDNF increase, because there's studies that have really been shown to do both of those things. So I would say in terms of the VO2 max improvements, what's been shown to be the most beneficial is the Norwegian 4x4 protocol that I mentioned, because for whatever reason, the longer intervals of going as hard as you can for a longer period of time, this is not all out. It's as hard as you can go and maintain for that duration of 4 minutes, right? And so it's going to be different for everyone, but you kind of have to pace yourself. And you
is
do
that something you do on a treadmill or a stationary bike or a rowing machine?
You can do it on any of them. I've been doing it on a rowing machine, but it was actually, I think, stationary bikes are what some of these other studies have shown as well. People can do running on a treadmill. I mean, you can kind of pick what you want. But the idea is you want to do 4 minutes at the highest intensity that you can maintain for that 4 minutes, which is not all out. You do recovery for 3 minutes at a very low intensity. And then you do that and you repeat it 4 times. So you do it 4 times. It's called the Norwegian 4x4. That's been shown to be one of the best ways to improve cardiorespiratory fitness. And in that study where the heart aging was reversed by 20 years, those people did it once a week. And so you can do that once a week. That's great. I do it on a Concept 2 rower, but you can do it on a bike. You can do it, whatever it is that works well for you, that you will be consistent in doing that. Now, I should also point out, if you've never really done high intensity interval training before, you're going to start out probably going a lot slower for your interval, and that's fine. Because
you're going to have to, because your capacity to recover during the rest aspect of the interval is not going to be, that great, right? So if you go too hard on the first one, you're not going to make it through the rest of the set.
Exactly. Yeah. And so for people that are interested in, like I said, there's a lot of different protocols out there for vigorous intensity exercise, improving a variety of different parameters. I do have a free guide called How to Train According to the Experts. And it's really according to all the experts that I've interviewed on my podcast in terms of like the different protocols for training and what they've been shown to improve. It's all evidence-based. People can find that out at howtotrainguide.com. And that's just a free guide. It's got awesome. All the different protocols. And then there's another protocol for the BDNF. So that would be what you can do to increase your brain-derived neurotrophic factor. There's also a variety of protocols that have been shown to do that. One of them is going at least 80 to 85% your max heart rate for 20 to 30 minutes. And that, I believe, was running, but you'd have to check. I have a free guide on that. And that guide is called bdnfprotocols.com. And it's a variety of different protocols that have been, shown to increase brain-derived neurotrophic factor if people are really specifically looking for that type of protocol, which is something, like I said, I myself am interested in looking at.
If somebody is extremely time crunched and they're like, how am I going to do my zone 2, my vigorous exercise and my strength training? Is there any wisdom or logic in creating a routine that is sort of a hybrid of all of those things? In other words, like a circuit training thing. So you're getting some strength, you're getting some, fitness. Maybe you're going from the rowing machine to the, whatever. Like you create this thing where your heart rate is very elevated and it's very difficult, but it's mixing in these different disciplines.
Yes, I would say the closest thing that I have found that I also do myself is a type of more CrossFit type of training. And so with this CrossFit type of training, often what's happened is, within an hour block of time, you start out with doing some strength training. So you can do barbells, you can do, whatever it is that you're going to be focused on that day, deadlifts, squats, a variety of different exercises. And then towards the tail end of the training is a workout. And the workout is a very circuit type of thing where you're incorporating a lot of high intensity interval training in with some of the strength training as well. But the strength training that the bulk of it is like at the front end of the workout. So So when you do the workout, you're doing a rowing machine or you're doing the bike or you're doing, any type of bike. So you could be doing the assault bike or, whatever type of bike you're, doing, jumping rope. And then you can incorporate some other aspects of, squats and deadlifts, other things like push-ups or dips, things like that as well. So I do think CrossFit type of training is a really great way, to incorporate all of those aspects for the HIIT and the strength training. But then you also want to make sure to get some of your like zone 2, whether that's running, which is my choice. That's what I choose for my zone 2. I like to do my runs on my recovery days, which are the days I'm not doing my HIIT and my CrossFit. Or you can do swimming, you can do biking, whatever it is that you enjoy and you will do. And I think the bottom line here is you have to find something that you do enjoy and try to, something that that you'll maintain and do, right?
Yeah.
And if you're just starting out, obviously, you're not going to be going really hard at first. It's a progressive program. You'll eventually get there, but just start out doing something, and then find what you like doing the most. Find what you enjoy the most.
Yeah. I mean, this is going to be published in the new year. Everyone's very excited about their fitness goals, and I think people just get maybe a little too excited and hit it a little bit too hard and suddenly find themselves in an unsustainable situation. So your point around like finding the thing you enjoy and not being in such a rush and just taking your time, like building something that, that you can perpetuate, that works within your life, but also that doesn't have to happen like overnight as a result, right? Because you are enjoying what you're doing.
Right.
So just going in and killing yourself and then being like, I can't do this anymore.
Well, I mean, that study that I talk about, the 2-year intervention study where these 50-year-olds reversed their aging heart by 20 years, these were people that were not physically active for like 50 years. And they started out, their first 6 months was a very slow, progressive workup to eventually working out 5 to 6 hours a week. So, it's not like they just started working out 5 to 6 hours a week, all vigorous, doing the Norwegian 4x4. No, it was a progressive loading, and it took about 6 months. And after that first 6 months, then they really started to get into it after the year. And then the second year, it was like they were going at it. But you have to, like you said, you have to allow yourself time. Don't get discouraged that on week 1, you're like not able to do, 5 hours of exercise in a week.
All right, let's shift gears. Microplastics. First of all, like what inspired you to get so interested in this area and invest as much time as you have trying to understand this world?
I would say what initially sparked my interest in microplastics were the chemicals associated with them. So plastic chemicals like BPA or BPS, the replacement for BPA, or phthalates, or the forever chemicals, PFAS. And the reason I was very interested in those chemicals associated with plastics and microplastics is because, I was looking to get pregnant. And so, enter, 8 years ago when I became pregnant, but I became interested in this a couple of years before that. So I was about 10 years ago, I got very interested in the effects of these plastic associated chemicals on the endocrine system. So these are, these particularly BPS and BPA, they're called endocrine disruptors. So they can disrupt our hormonal system, and they largely do that because they're mimicking estrogen. So they're called xenoestrogens. And I knew that pregnancy is a very sensitive period of time, and I wanted to make sure that I was, doing everything I could to, give my future child the best chance it had. So that's where I really got interested in. So the plastic associated chemicals, fast forward 10 years, I would say in the past couple of years, microplastic stuff started coming out in headlines. And because I've already sort of been very interested in the plastic associated chemicals, I was like, gravitated towards wanting to understand that as well. But that's where my initial interest came from.
The minute you start raising the alarm around microplastics. It does have like a ring of being alarmist. There's something sort of Cassandra about it. Like, what are we really talking about here? Is this really something we should be worried about? Like, this stuff is everywhere. People are, seem to live with it fine. Is this not just something, on the margins, like a micro problem, microplastics, right? So maybe make the case for why we should take this seriously and be concerned and educate ourselves around like the toxins in the world that are impacting our health.
Yeah, I think that you make a really good argument there, or, case point that humans are pretty robust. We're pretty resilient, right? I mean, we can be challenged with things and deal with them. I would say that, first of all, microplastics, people may be wondering, well, what the heck is microplastics,
yeah, maybe
right?
We should define our terms a little bit.
Well, we all know plastic is everywhere, right? It's everywhere. Just walk into a grocery store. Look, open your refrigerator. Just walk into your pantry. You'll see plastic. Plastic is everywhere. So microplastics they occur from the breakdown of larger plastic particles. So oxidation, that same process we were talking about, oxidation degrades plastic into smaller plastic particles. And microplastics can range in size anywhere from, 5 millimeters. So that would be like the size of a grain of rice, all the way down to like 20 nanometers, which would be 1,000 times smaller than a grain of sand, something that you wouldn't be able to see with your naked eye. And when they get that small in size, they're technically nanoplastics, but largely the term microplastics, it sort of includes the nanoplastics as well. And so these microplastics, most of the time we can't see them. I mean, we're not seeing them. They're contaminated we can talk about all the sources if you want later where they're found, but essentially we're consuming them, through our water and our foods, and we're also breathing them in through the air. Those are the two main ways they're getting into our body. And you say, make the case, like, is there a case that they're actually bad, that we should care about it? And I would say that we're really in the infancy in understanding microplastics and what they're doing to human health. Really, a bulk of the studies have come out actually this past year, 2024. Interestingly, I think scientists have been starting to study it in the past couple of years, and now studies are being published now, and I think it's going to continue to accelerate in terms of our understanding of their impact on human health. But what I can say right now is there was a study published in 2024. The study came out of Sao Paulo, Brazil. And that study had looked at microplastics in a variety of different organs and found that it was accumulating in the brain, human brains, about 10 times the rate of other organs, which to me was very alarming because blood-brain barrier is supposed to protect our brain. And in fact, if you would have asked me, Rhonda, what organ do you think is going to have the least amount of microplastics? I would say the brain, because our blood-brain barrier is going to protect us from having, these microplastics in our brain. And so that was very confusing to me when I first read that study. So it turns out a couple of things. One is that these small microplastics, the nanoplastics, these things can traverse membranes very easy, including our gut epithelia. They can get into the blood-brain barrier very easily because they're very, very small in size. But that's not the reason probably that the microplastics are accumulating in the brain. I think the reason they're accumulating in the brain is because we are breathing them in. And so we have olfactory neurons in our nose, right? That's responsible for detecting odor. Well, there's a direct connection to the central nervous system. The olfactory pathway has like these axons that directly connect to our brain. And so you can inhale stuff through your nose, and it's a way to bypass the blood-brain barrier. I mean, this is why some people are given drugs that are not able to be administered through the blood stream because they won't cross the blood-brain barrier, but they can be inhaled. So
anything that you inhale will pass through the blood-brain barrier? That can't be true.
I don't know that anything that you inhale, but a very small particle that is like a nanometer size can get across the blood-brain barrier.
I see. As an environ versus like being in your bloodstream and then running into a problem when it reaches your brain.
So there's two ways it's getting into the brain. And look, we don't really know why the brain is accumulating 10 times more microplastics than other organs, and that more larger studies need to confirm this. This is all in its infancy. But I'm just saying a couple of probable mechanisms to explain it, just knowing what I know about, how particles and microplastics are in the air and how we are breathing them in, and how that is another way to get into the brain as well. But I think what was the most alarming about this study was that the individuals this was all postmortem, of course, and some people, if you get a population sample of people, there's going to be a certain percentage of people that have Alzheimer's disease. Well, the people that had Alzheimer's disease in this study were 10 to 20 times more likely to have microplastic particles in their brain than people that did not have Alzheimer's disease. So there was not only are these particles accumulating in the brain, it seems to be very tightly correlated to people that had Alzheimer's disease. And we know that from animal studies, when you have these small particulate matter in the brain, it is a activator of the inflammatory response. And neuroinflammation is a well-known driver of neurodegenerative disease, including Alzheimer's disease. It's just well-known, neuroinflammation. So that, I would say, is again, this is all in its infancy, but it's the first piece of evidence that to me is like, oh, microplastics are in our brains. They're really accumulating there, and they seem to be tightly associated with Alzheimer's disease. We know they cause neuroinflammation. This is something that we need to understand better. I would say the other study that was also published this year, it was in the New England Journal of Medicine, which is a pretty reputable journal. That study looked at patients that were undergoing cardiac surgery and found that close to 50% or so of these patients had microplastic particles lodged in their arterial walls. And it turns out that, throughout the follow-up duration of the study, which was 3 years, those individuals that had the microplastic particles lodged in their arterial walls were 4.5 times more likely to experience a heart attack or a stroke within that 3-year follow-up than the people without microplastics.
Is there a relationship between the microplastics lodged in the arterial walls and how that impacts like plaque buildup or plaques getting caught loose? Because perhaps somebody who has that is having heart issues because they're consuming so many products that are wrapped in plastic and, by definition is sort of in the ultra processed world.
Right. I think that's a great point. So the particles do cause inflammation. Like those mechanistic studies have been done. Mm-hmm. Inflammation is a major driver of atherosclerosis, right? So it's affecting that whole process, right? Of like the plaque and the foam cell formation around. So the macrophages come when there's an inflammatory response, and then they get all trapped with the plaque and it forms these foam cells. And so it is a major driver of that process, the inflammation is in the cardiovascular system. But I do think that you're making a good point, and that is it's hard to uncouple, people that are eating diets that are
if you're eating if you have a lot of microplastic in your brain and your body, like you're probably not living the healthiest lifestyle at the same time. Part of it is environmental and unavoidable, but at the same time, if you have an excessive amount of it, like maybe you're just putting your plastic wrapped food in the microwave every day.
Right.
And that's probably not good either. Right. So like that's contributing as well.
Absolutely. Absolutely. I think that's a very good point that can't be dismissed for sure. On the other hand, these microplastics are pervasive and they're everywhere, and they're in our water, and they're in our fish that we're consuming, and there could be they're in our vegetables. So there is an argument to be made that, well, you could be eating healthy and think you're eating healthy and still getting a lot of microplastic particles and not realize that. Like you could be drinking bottled water out of a plastic bottle and still be going to the gym and still eating healthy and not realize that the water that you're drinking out of the plastic bottle is, shedding microplastics. And so heat, as you mentioned, heat in the microwave, heat accelerates that oxidation process. And so it really rapidly causes more microplastics to be shed into the beverages or into foods, but also the chemicals associated with them also. So there was a study showing that like boiling water can cause BPA, which is a plastic-associated chemical endocrine disruptor, to leach into the liquid by like 55 times higher. So heat really does accelerate that whole process of leaching the microplastics and their chemicals into our beverages, into our foods. This is particulate matter. And once it's getting into our organs, it doesn't have a way out, So the fact that the inflammatory response that it's causing wouldn't be doing anything is, to me, hard to believe. And then on top of that, you have the plastic-associated chemicals, right? So there's chemicals that are also in those microplastics, right? So you've got BPA and BPS. Those are probably the two main ones that are in those types of plastics. And those we know also have detrimental effects, right? It's hard to imagine that it's not affecting it in a causal way, but you're right. There's likely other confounding factors. In other words, people that are eating more processed foods are likely consuming more microplastics because processed foods are packaged in plastics, right? For one. So, I mean, it is kind of hard to uncouple those things. But I do think that, so the microplastics themselves, I think those are the two main studies that have caused me alarm. And then the third one is that there was a study that looked at microplastics in both human and dog semen. And it was found in 100% of both human and dog semen. Like every single sample measured had microplastics.
Wow.
And that was associated with also changes in motility. So in other words, like the ability of sperm to move, swim, and also morphology, so the shape of it. And so, is it affecting fertility? Well, we know motility and morphology play a role in fertility, so likely. We do know that the chemicals associated with microplastics like BPA play a role in fertility. There's been studies looking at women that have higher urinary BPA excretion that are undergoing in vitro fertilization, IVF. They have half as many viable eggs if they have higher urinary BPA compared to women that have lower urinary BPA. And they also are, their implantation success rate is much lower as well. So it is impacting fertility in both men and women. At least we know the chemicals associated with them are. Again, the microplastics themselves, like this is a really new field, and our understanding of it is just in its infancy in terms of understanding what it's doing to human health. The scary thing to me is that it is contaminated in our water sources. So it's in our tap water. It's certainly, if you're drinking out of a plastic bottle, you're getting even more plastic particles. But it's in our soil. And a lot of the sludge that's used as fertilizer is contaminated with microplastics, and that's largely because wastewater treatment plants, they treat for like pathogens and things like that. They don't treat for microplastics. Like those aren't being eliminated. And the same goes for like forever chemicals are contaminated in our sludge. And those are really problematic because, unlike BPA, which has a half-life of a couple of hours in our body, forever chemicals have a half-life of like 3 to 5 years. And they're associated with cancer and all kinds of effects. Yeah. PFAS, yeah, and they're contaminated in our soils, and so they're making our way into our produce. Washing the produce helps, but I mean it's in our oceans, and so fish have become contaminated with microplastics. It's shellfish are probably the biggest ones to avoid because the microplastics are in the digestive system of the fish. And so if you're eating the whole like clam or like an oyster, you're eating everything.
Those animals are just filters.
Exactly.
So basically they're just accumulating it and accumulating it. And it really is a much more profound issue than like, hey, don't drink out of a plastic bottle or don't like put your food in the microwave because of the water table and the oceans and the soil. So even the most diligent among us who is avoiding purchasing anything wrapped in plastic or plastic products in general, if you're eating food, basically you're getting it because the animals are, in the soil and drinking the water, et cetera, and they're filtering this as well and accumulating these things. So you're getting them in an even higher concentration, perhaps, depending upon the animal and what it was fed and where it lived, et cetera. But the real kind of brain fuck in this whole thing is the fact that it's breathable, that it's in the air, that we're inhaling it. And you said this amazing thing, which is that what did you say? Each week, the average person inhales an equivalent of a 5-gram credit card in plastic just by breathing.
Okay, I'm glad you brought this up.
Is this true?
Because
have you modified your, like, what is this real?
So turns out the study that I cited for that had a methodological flaw.
Okay.
Which I did not know until after I released my episode on microplastics. And that is that when you're trying to look at the gram weight, so we are inhaling a lot of microplastic particles, yes. So microplastics make up all the tires, there's these synthetic, tires and stuff that are, it's not just rubber, it's made of these other plastic materials. Every time all these cars on the road are driving, it's releasing it into the air, right? And also our shoes, dryers, so our clothing, my dress, like all of our clothing that's not 100% natural fiber, when we wash it, it's going into the water. And then when we use the dryer, it's being released into the air. So we are inhaling a lot of microplastics. But it turns out the study that I quoted and many others have quoted, when they were trying to figure out particle and then weight, they were there's different size particles, as I mentioned, right? You've got the grain of rice, and then you've got 1,000 times smaller than a grain of sand. Mm-hmm. Very different sizes here. And so when you're trying to estimate a weight, it's almost impossible. It's almost impossible. And that study that said it was a 5-gram weight used a lot of microplastic particles that were based out of the ocean as their reference point to calculate the gram weight. And I don't know that we can necessarily say, well, that's the size particles that we're inhaling and consuming, everything that's in the ocean, right? So I would say my updated version of, that would be, depending on your lifestyle, people are consuming hundreds to thousands of particles, microplastic particles a day, both inhaling and consuming. So, I can't give you the gram weight of that because I don't know that. In fact, I'm questioning if anyone can really accurately give a gram weight because there's so many different size variations in these particles. It's just impossible to actually be able to do that.
Whether or not it's a credit card doesn't matter. You're breathing it in, you're eating it, it's going into your skin, the clothes you wear. Like it's all around us, right? So what aspect of this is something we should really be alarmed about? Because like there's only so much control that we can exert over our environment. And I don't want to fearmonger. I want to provide people with information and practical solutions that they can incorporate into their life. So maybe talk a little bit about what we should really kind of pay attention to, like what are the worst offenders that we can actually do something about and make changes around.
Okay. Yeah, I think that sounds good. I want to mention, I would say some of the studies looking at the plastic-associated chemicals are the strongest because we have many, many years of data with that. And so should we be worried about microplastics that are carrying BPA in them? I think we should. Mm-hmm. I mentioned the fertility, but we also know that pregnant women that have higher urinary BPA levels are 6 times more likely to have a child diagnosed with autism by the age 11.
Wow.
6 times more likely. And this is not just one study. Okay. Multiple studies have shown this. And it's not just autism. There's a spectrum of neurodevelopmental disorders, including ADHD, anxiety. Urinary BPA is associated with all of these neurodevelopmental disorders. And also, children with autism have been shown to have up to 15 times higher urinary BPA. They're not able to excrete it as well. So there's something funny going on there. So I do think there is, again, and we know some mechanism involved because BPA is a xenoestrogen. It is binding to estrogen receptors. It could be competing with estrogen. It also affects the aromatase enzyme. So this is the enzyme that converts testosterone into estrogen. It's very, very important during development, especially, brain development for a male fetus. Estrogen plays a very important role in the developing male brain. And when you disrupt that hormonal balance, it can lead to neurodevelopmental defects. And that's been shown mechanistically in animal studies. There have also been studies showing that children with disrupted aromatase enzymes are more likely to have autism. So it's something to pay attention to, BPA. And that's with respect to, of course, we're talking about development. I already talked about fertility, but also the cardiovascular system. And so there have been studies showing that people consuming canned soup out of a cans are lined with BPA because they have plastic lining to protect the food from corroding it, right? Those individuals they have like 1,000-fold higher BPA after consuming canned soup versus the people that consume the very same soup out of a glass jar. 1,000-fold higher BPA. That's insane. Another separate studies have shown that that people consuming canned soup, again, we know it increases BPA, have a 16-fold higher increase in their blood pressure compared to people that are consuming soup out of, not canned soup out of a jar. So a 16-fold increase in blood pressure, I want to just say for people that might go, wow, that's a lot. It actually translates to about a 4.5 millimeter mercury increase. So it's not super, super high increase, but it's 16-fold higher than the people that didn't consume the canned soup. We know that BPA is affecting hormones, but it's also affecting calcium signaling in the vascular system, very important for the way our blood vessels contract, dilate. So BPA is affecting cardiovascular health. There's also been studies looking at people with the highest urinary BPA. They have a much, much higher elevated risk of cardiovascular disease. Again, we can't avoid the confounder effect of perhaps these people are eating terrible diets as well, right? That's something to consider. But I do think the case of looking at some of these plastic-associated chemicals, because we have a lot more data on that, is stronger right now, at least. I won't know that that's going to be the case in 5 years where we'll have a lot more data on microplastics themselves. But I do think that makes a case of concern for our children developing, child development, for fertility, cardiovascular health.
Cancer risk.
Cancer risk. That's another one.
Cancer risk also has been shown based upon what I've heard you say.
Right. Yes. So there's cancer risk, and that's also with other chemicals like the phthalates, and then the forever chemicals, the PFAS. Both of those are associated with cancer risk as well. So there is, I think there's a reason to be concerned about plastic and plastic in our bodies and plastic chemicals in our bodies. Now, what can we do? Obviously, like your question was, okay, well, we can't avoid it.
Right. And let me just interject one other point, which I think is important. This problem is not going away. It seems to be increasing quite rapidly. I heard you say basically that there's a study that has shown a 50% increase in microplastics between 2016 and 2024 in terms of like what they're finding in people's bodies. I mean, how did they do that study or determine that figure? It was
actually a part of that same study, the Brazilian study, where they were looking at they were just, looking at these cadavers and doing, looking at the organs from autopsies done, X many years ago versus today. And I've been trying to wrap my brain around that too, because, when I think about it, I'm like, well, 2016 plastic was here, so.
Yeah, like what changed?
Right. What changed? And I don't know the answer to that. I just, it's something to think about. Like, I don't know why that is. Like, is it because it's that it's just accumulating more in our environment? I don't exactly know, but I do know there is a lot more single-use plastic now, and to go. I mean, it seems like a lot. I do see a lot more plastic in terms of like these packaging our foods, making it easier for us to just get these to-go foods. Like, that's definitely something that I've seen increase gradually. That's the only thing that I can think of. The other thing is it just accumulating more in our foods now that we're eating? And so now it's taken some time, and now I don't really know, to be honest. But it is something to think about. Whether it's like the end-all be-all truth, I'm not sure. It's just one study. So I think more evidence needs to be.
Yeah, I mean, you would think as it continues to accumulate in the soil and in our oceans and in our water table, that is a buildup that is going to show up in an autopsy.
Right. And that could be very well what's happening, right? I mean, that could be what's happening.
Mm-hmm.
But when I think back to 2016, I still think there was a lot of plastic back then too. So I'm just sort of thinking out loud.
Since then, we've made a lot more plastic and like spread it around, right?
That's probably what's happening.
Yeah,
that's probably what's happening.
All right. Well, let's go into the things that we can do. Like, what is the in terms of like risk and danger? Like, where should our attention be focused?
I think that's a really good question because otherwise you can drive yourself literally crazy.
Yeah, I mean, it's paralyzing, right?
It is.
You don't want to be like the boy in the bubble, and
right.
God forbid that bubble is made out of plastic, right?
Right. Yeah. Exactly.
Like, what are you going to do then?
Like Howard Hughes, you're going to be like in the room, and you're going to
and you're like, and turn the heat up, and then all that plastic from the bubble. Oh no.
So I think the worst offenders, right? So it's sort of like an imperfect solution, but really like you really want to sort of avoid the worst offenders. When it comes to the worst offenders, first of all, heating plastic, absolutely a no. So you want to, of course, never microwave anything in plastic. But also you have to think about these plastic bottles of water. Like, yeah, they're cold when you go into the CVS and grab it out of the fridge, but like, was it cold when it was on the freight train or the boat or wherever it was to get there? And how long has it been there in the warehouse before it was in the fridge and probably been exposed to some heat?
In some shipping container,
right?
Coming overseas in the South Pacific or something.
Right.
Who knows?
I would say now there's cases like when you're traveling, it's kind of hard to avoid water out of a plastic bottle, but for the most part, trying to not drink water out of a plastic bottle is really advisable because that is a big source of microplastics. And then if you can get first of all, any type of activated carbon filter will filter out a lot of the plastic associated chemicals. But if you really want to filter out all these microplastics in all their sizes, including nanoplastics, a reverse osmosis filter at home, whether it's a tabletop one that you just drink your water out of or it's a whole home filtration system, is the way to go because it does filter out even the nanoplastics. Now, the thing to consider with that is also it filters out essential minerals and trace elements. So you will have to make sure you're taking a nice mineral supplement, or you can even get some drops that are in like a glass bottle to add back to the water, mineral drops they make that you can add back to the water to make sure you're getting those essential minerals and trace elements back in the water. What are
the important minerals that it's filtering out?
There's a whole list of them.
Okay,
there's
another 4 hour
Yeah,
whatever.
I mean, it's like magnesium and calcium and manganese and iodine and lithium. Like there's a whole list of chemicals that are filtered out that are usually in the water. So you want to make sure that you're like if you're taking a multivitamin supplement, most of your bases are going to be covered probably. But there's also some mineral supplements out there that are just like it's like the mineral supplement, and that covers all the ones that are filtered out from reverse osmosis. Alternatively, some people like to get these drops that are specifically made for people that have reverse osmosis filters. And you want to get one that's in like a glass container, not plastic. And then you want to introduce those into your water. There's also filtration systems that will reintroduce the minerals back in. However, I'm not sure if those filtration systems are made of plastic. So you don't want to reintroduce the plastic after you just filtered it out. So,
oh my God,
you have
That's
to think.
Crazy. Yeah. But I guess, look, there's a million different water filtration systems out there. It's sort of dizzying, for the average consumer, as long as it's
reverse
osmosis variety,
exactly.
You're going to be okay.
You're going to be, you're like 95% there. Right.
And on the topic of plastic bottles, is there any wisdom at all in, not all plastic is the same, right? Like there are different types of plastic bottles and you look underneath and there's the number and this is plastic safe, et cetera. Is that all bunk from your perspective, as long as it's plastic? Because there's those really thin ones that are crinkly. You know, obviously, that this is not good, right?
Yeah.
And then there's the thicker, more robust, like, Gatorade comes in it, so you're like, well, these aren't exactly the same.
Yes, you bring up a good point. So the crinkly ones are more like, those are like degrading, like they're degrading as you're holding it, in your hand. Yeah. So that's the whole thing, that the microplastics are being shed through the degradation process. I would say the black plastics are the ones to really avoid, and those are the reason for that is there was a study that was published last October. The problem with the black plastic, so think sushi container. Or
any takeout,
or a rotisserie thing. Or any takeaway, right? Rotisserie chicken container or takeout, container, or those black forks, that you have at parties or whatever. Those are often, not always, but often made of recycled plastic from recycled electronics. And the study that was published, I forgot the name of a journal. It was some kind of environmental, health journal. That journal found that those black plastics, like the black plastic spatula, for example, those plastics contain a variety of chemicals that are known carcinogens. So they have flame retardants in them, things that are just bad chemicals. And so they seem to be even worse. So you're really avoiding the black plastic, and especially heating those, right? So you think of your to-go food, it's going hot on the black plastic, that's causing those chemicals to leach into your food even more. I mentioned that heat, causes the leaching of chemicals like BPA 55 times more. So you really want to try to avoid those black plastics also. The other main offenders would be to-go coffee mugs. Most to-go coffee mugs are lined with plastic. And that plastic breaks down with heat and BPA, and those are you're drinking
hot. Yeah, something hot in there.
Yeah.
So exactly. Is it the same lining that you would find inside a canned soup or a can of beans?
It is. Yeah, it is. And then also in a can of sparkling water, right? Those cans are lined. Aluminum cans are lined with plastic lining to protect the aluminum from corrosion from the beverage or food. So you think you're avoiding the plastic by drinking out of a can. Turns out you're actually drinking out of a plastic-lined can. And
oh God.
So if you can not drink those every day.
Right. I had heard about the black plastics, but the way I heard about it was through the spatula version, right? I hadn't thought about the to-go food packaging and all of that. And I think it brings up another issue that maybe deserves a little elaboration, which is the difference between what we think of as single-use plastic and then the kind of plastic that we all have in our houses, whether it's a spatula or some other version of which is robust and thick, and you're like, well, this isn't a single-use plastic. This is probably okay.
No, especially if you're cooking with it, right? Because cooking heat is accelerating that whole degradation process. You are shedding microplastics and chemicals into the food. So you want to get wooden cooking utensils. And also, I would say, you can use the stainless steel as well, but you want to use stainless steel on a stainless steel pan. But avoiding also the pans lined with non-stick stuff, right? Because that has forever chemicals in it, the Teflon stuff. So I still, if you're putting heat in any way, shape, or form on any type of plastic, how robust it seems, it doesn't matter, because the heat is really what's breaking that down. It's breaking it down, and it's leaching into the food or the beverage. So the heat is the thing you're talking about avoiding the worst offenders. Really, it's heat. So anything that's going to have heat with your plastic, big time, try to avoid that. The water filter is another one. And then, shellfish, probably not something to eat all the time. It's okay once in a while, right? But the shellfish they have, unfortunately, a lot of microplastics in them. And fish do as well, as long as you're not eating the digestive system of the fish, But it's in fish. Produce as well, but you wash your produce, you're better off. You're not avoiding the food packaged in the plastics. Now, your strawberries come in a plastic container, and so you have to wash your strawberries really good, right? Because it does shed shed particles. Now, it's not like those strawberries have been in that plastic container for that long. So it's not likely that it's shedding tons and tons and tons of particles into your strawberries, right? It's more likely that the strawberries took it up from the soil that's been contaminated with the plastic. But I think in terms of consumption, those are the main things to sort of avoid, those worst offenders. And then with respect to breathing it in, right? Like getting a high quality HEPA filter for your house, several rooms in your house. I mean, they're not that expensive, and you can have them, in multiple, certainly in the room you're sleeping in. So getting a HEPA filter can filter out some of those microplastics as well, because they are in our circulation. We do breathe them in. Unfortunately, using a dryer, making sure that you're having good, proper ventilation, that it's ventilating outside is very important, right? Because the microplastics are coming from our clothing. Right. In fact, our clothing is one of the major sources, aside from the breakdown of the large plastic trash in our ocean, which is the major cause of the microplastics in our ocean. Our clothing is the second major cause. So when we are all of our clothing that's made of all these mixed fibers, when we wash them, that runoff is going into the ocean, and it's full of microplastics. So are the nanoplastics part of the clothing also that are being absorbed into our skin? Do we know this or not? Like I'm thinking of like maybe these are like edge cases. Yeah. Like this is getting into neurosis land. I'm thinking about like my Vitamix. I've been there.
I have a Vitamix. It's plastic.
Oh no, get the stainless steel one.
But it's thick. Yeah, like I have the plastic one. It's a thick plastic, but sometimes like we're putting something hot in that and blending it up, and I'm thinking like I probably shouldn't do that anymore.
No, yeah, I did the same thing. I actually just got in the past few months since I did this deep dive.
I didn't know there was a stainless steel.
There's a stainless steel Vitamix container. I got it a few months ago, and it's great. I got it for my in-laws. Anyone in my family that uses Vitamix, I'm like, no, you need to get this. It's $200. It goes on. Just get the container because it'll fit on your Vitamix that you have. Unfortunately, friction does increase the shedding of microplastics, so blending itself also affects it. But yeah, I was doing the same thing. And
I mean, I don't want to be neurotic,
Yeah, what I mean, look, you can take this to the X degree, right? Like you can definitely go down that rabbit hole. But if there is a stainless steel Vitamix container, why not get it if you can? It's not super expensive, and it's not going to hurt. So why not get it? I would say, but that's not the main focus. I would say we've discussed the worst offenders, right?
Talk to me about how salt contributes to this problem.
Yeah. So salt, especially sea salt, right? If you're getting sea salt, you're getting it from the ocean, which is polluted with microplastics. So sea salt is a contributor of microplastics to people. And
you buy it in a little plastic jar.
And it's in a plastic container. Exactly. And so if you're going to use salt, it's better to get like a rock salt, like, pink Himalayan salt, which also does have microplastics, but less. It has fewer particles than sea salt does. So salt is also a contributor. I don't know that it's the main contributor, but if you're using salt, go for the Himalayan salt rather than the sea salt, or even the Morton's, like the old Morton's salt, that was like at everyone's table 20 years ago. Those are rock salts as well.
And should we be concerned about the receipts that we're given every single day?
Yes.
Like I've heard a lot about this. Is there truth to this? I mean, I avoid like putting my hands on it just because this is what I've heard, but I haven't read the studies. I don't know how robust of a problem this actually is.
So receipts are made of thermal paper, which are just heavily coated with BPA. And I think the first study came out, almost 10 years ago. I remember reading it 10 years ago. And it was a study that was looking at people that had put lotion on their hands and then touched the thermal paper, the receipt. And it was like the BPA that got into their circulation was like astronomical. I mean, so usually transdermal absorption isn't that big of a deal. Like, so we're talking about our clothing. It's not like I'm absorbing microplastics through my skin very easily from the clothing I'm wearing. It's really
more about what ends up in the water table as a result.
Yeah. And sometimes, if you're exercising in that clothing, maybe you're getting some particles, but the majority of the particles that you're breathing in are not coming from your clothes directly. They're coming from the air, from the other sources, right? But I do think that people I also try to avoid receipts. And so I always opt for no receipt or can you trash it for me? But I do think people that work in industry where they're every day
handling them all day long. Yeah.
They should be wearing nitrile gloves. So that there have been now studies showing that people that handle thermal paper, which is the receipts, and they wear nitrile gloves, that blocks the BPA from being absorbed in their skin. And so I don't think Latex did the same thing. It really had to be a nitrile glove. So anyone that's in that industry that's handling receipts daily really should be wearing gloves. It should be something that I think all companies employ, like to protect people don't know about this, right?
Mm-hmm.
I think that they should be told. So, you've got like pregnant women working behind a cash register and dealing with those BPA receipts. And I told you, the study came out showing that, pregnant women with higher urinary BPA have 6-fold, higher likelihood of having a child with autism. So, there are little steps that can be taken that I think, there's a big bang for your buck. Right.
Yeah.
And certainly if you're working in an industry where you're handling receipts, you should be wearing nitrile gloves.
What is your sense of the kind of regulatory landscape around all of this? It doesn't seem like we're really doing very much here. There is a lot more discourse about this and people are talking about it. Are there measures afoot to address this in any kind of macro way to prevent these things or outlaw certain, uses of plastic?
Look,
this is too profligate. It's like everywhere.
I don't think enough is being done for sure. So, I'll tell you this. I was talking about the sludge that's put, as used as fertilizer like this. So this is typically from waste water, right? A lot of organic farms are not allowed to use sludge, but it somehow ends up in organic farms anyways. And there was a study that came out, was it last summer even, looking at, it was a Consumer Lab report. It came out where Consumer Lab was looking at forever chemicals, so the PFAS, and they're contaminated in our water sources, in our soil, they're in the grass. And, Consumer Lab had went to a variety of different grocery stores around the country and looked at organic milk, grass-fed organic milk, or, conventional milk, and sampled for these forever chemicals. Mind you, forever chemicals are linked with cancer and they stay in our bodies for years. We can't get rid of them. It turns out cows, which are eating grass, which is contaminated with the forever chemicals, do get rid of them and they excrete them through their milk. And so Consumer Reports found that there are some milks that I've even bought before. It's like the grass-fed, organic Grass Valley, like the stuff that you think is the best.
That's the worst.
And it's contaminated.
For that aspect of it. Wow.
Contaminated with forever chemicals. And it's these companies know about it. Not every single one of their products was, but it's something's going on here. Something's going on here. And some of these were at levels that were exceedingly high.
Mm-hmm.
And so, it's at a point where it's okay, why is the FDA not coming in and going, hey, you guys need to test for forever chemicals. You need to test for microplastics and make sure the products that you're putting on the shelves don't have high levels. Like Topo Chico is another one, right? There was a big consumer report.
I remember when that was a big thing.
Yeah, 2020, It came out where it's all these brands of sparkling water were contaminated with forever chemicals. And Topo Chico was the top of the list. It was at astronomical levels. They claim that they've gone down since then, but there's no data to show that. So it's okay, well,
there's no disincentive really except the consumer market.
Right.
It's not like anybody held them to account.
And nobody knows about it. You tell people, they're oh, what? Really? This isn't common knowledge. And so, I think that the FDA needs to come in and there needs to be standards set where it's look, you need to test your products for forever chemicals, for BPA, for microplastics. We need to not be giving people, large quantities of this. You need to care about it. It's important. And that hasn't been done.
No, I know. Yeah, I've had this conversation with Erin Brockovich. Her whole life is about this, and it's still such an uphill battle. I had Greg Renfrew in here, who founded the company Beauty Counter, which is like clean beauty products. And her whole thing is the chemicals that find their way into the cosmetic and beauty industry. And her basic thing is like, this is not regulated at all. It's like safe until proven guilty, and all these chemicals end up in all these products that we put in our skin and on our in our mouth and all the like, and it's all fine, until it's not, right? Like, because there's just so many of these chemicals,
and that's probably one of the most, I would say, deceptive examples of it, because it's something that I wish I had focused more on. I would say, like, during my pregnancy, was some of these chemicals that are disguised in our cosmetics and our shampoos and our creams and our lotions, because phthalates are probably one of the things that was discussed. And that's something that's really, it's in all our hygiene products. And so I was looking for the phthalates, but it's disguised under the word fragrance or parfum. And it's like, I didn't know
Which
that.
can mean anything.
I didn't know that. Yeah. And so that if it says like fragrance or parfum in your, list of chemical ingredients, then it's phthalates. And that has a profound effect on not only cancer, but like during pregnancy. It's hard to deny the evidence now that it's associated with urogenital defects in boys. So it's affecting it's causing undescended testicles, and it's causing hypospadia. So like their urethra is like moved further back. So, it's harder for like boys to pee like a stream. I mean, this is something, by the way, that's been increasing in prevalence over time. Like, I can't tell you how many moms I know, they're like, oh yeah, my son has undescended testicles. And it's like, why is this so common now?
I didn't even know that is a common thing.
No, it's really common. It's become really common, and it's linked to phthalates. And again, it's like, why is it allowed in all these products? And why is it allowed to be disguised under this word of like, why do I have to call the company up and ask them? Like, that shouldn't be the case. That should be listed, or it should be regulated. Like, how much evidence do we need to show that, look, there are effects happening from these chemicals, from whether it's the phthalates or the BPA or the BPS, all these things that are labeled as BPA free. Like, I have so many friends who are like, oh, I'm fine. I get BPA free plastic. And I'm like, you realize that the stuff that they replace BPA with is just the same or worse. It's also an endocrine disruptor doing the same things. And it's just a brilliant marketing strategy where now these companies that are selling BPA-free plastic are selling it to the people that think they're, getting a healthier type of plastic, when really it's just same old plastic with a different chemical doing the same thing, right? So, it's.
I shouldn't be laughing.
No, it's not.
It's really awful that this is the state of affairs.
It is, and also that like we have. We've got these regulatory agencies like the FDA. Like, we have so much evidence now. Like, how much evidence do you need to show that there's harmful effects of these chemicals, getting into our foods, into our water, contaminating our milk? Like, forever chemicals in milk? Like, I would never have thought that. I'm worried about yogurt, butter. The forever chemicals are hydrophobic. They like to accumulate in hydrophobic things, so they like to accumulate in fatty things. So the butter, I'm like, okay, this Kerrygold grass-fed butter that everyone thinks is so great, maybe it's got forever. We don't even know. There's nothing that we can do to test it until we have like a third-party testing, like Consumer Reports, come out with this thing. Then it opens our eyes for like a month, and then everyone forgets about it, or at least people that read about it forget about it. And yet nothing's being done, and
what is your sense of why the FDA or the EPA isn't all about this? Is it that they're captured by, corporate interest? Is it because they're dealing with too many other things, or it's too big of a problem?
Probably all of the above.
Or they don't care.
Probably
or
all the above.
It hasn't risen to the level of attention that, like sort of public uproar for them to do anything about.
Yeah, I think there's probably a combination of all those factors, right? I mean, plastic is everywhere. Like, how are you going to get rid of everything's in plastic? So it's probably a hard problem to solve. I do think there are certain ways that you can tackle it, like especially when it comes to chemicals that are contaminating the water, like the forever chemicals, like that you can put a limitation and say, hey, like, you need to test your products, and if they are contaminated, first of all, don't sell them. If it's above a certain level, put it on it needs to be labeled. This has PFAS in it. Guess what? People will stop buying it, and eventually the company will care more about trying to eliminate the PFAS if it's labeled. Like we have trans fats labeled everywhere. Zero trans fat, zero trans fat, zero trans fat. Okay, everybody knows trans fats are bad, right? We have a lot of data on that. We have a lot of data on these endocrine disrupting chemicals. We don't have as much data on the microplastics themselves yet, but we do have a lot of data on the chemicals associated with them. And, I think it's time that things start to get labeled. Is there BPA in this? Is there PFAS? How much? It's a simple test that can be done. They can do it. And I think if there's enough pressure if the consumer is saying, I'm not going to buy this, I'm going to opt for the one that's not contaminated, then maybe there'll be enough pressure on the company to make a change. Like maybe that's the way to go.
When it's in everything, then it's in all the things that you need to make the things.
I know.
You know what I mean? It becomes an intractable problem. And also, I think the defense perhaps has something to do with the fact that the amounts are so micro, so trace, as to be kind of, easy to, dismiss. Like it's so small in here. Like you can't make us put a label on it that says it has. But the problem is, because our exposure is so chronic to everything in our environment, we're accumulating them. So it isn't any one thing. It's the aggregate exposure of all of it that is victimizing us.
Well, also, I do think that, if you even look at some of the like relative amounts, like if you looked at the sparkling water data that came out in 2020, Topo Chico was like 9.76 parts per million, whereas something like Pellegrino was, I don't know if it was 0.01 or 0.1. Either way, big difference there. Big difference,
Understood.
right?
Yeah,
and so it's like, well, if I'm drinking 3 or 4 bottles of Topo Chico every day and forever chemicals stay in my body for 3 to 5 years, I don't know. That seems like a problem here. And I think that's something, particularly with the forever chemicals, that I think that is one area that FDA needs to step in because of the persistence in our body for so long. And the fact that it's now contaminating our grass, the cows that are eating the grass, you think that the cows eating the corn, I'm trying to avoid the corn-fed cows. Turns out the grass-fed cows are getting all these forever chemicals because our soil is polluted with it. And it's like, so, I just think it's unacceptable for our milk to be contaminated, our organic grass-fed milk to be contaminated with high levels of these forever chemicals. It's just really not acceptable. I think something needs to be done about it. The question is, how do you go around it? I do think that if you start to label things, and you're right though, like if it's like a small amount, and that's the same goes with trans fats. Like a product can contain a very trace amount of trans fat and be labeled zero trans fat because it's considered to be, a trace amount, right? But I do think that if we start labeling things, then that probably would make a difference. When people, first of all, it increases awareness. First of all, people go, oh, what's PFAS? And they look into it and they read about it and they go, oh, this is something to be worried about. Okay, I'm going to start looking for foods that don't have that.
Are there other countries that do this or that are ahead of us in this regard?
No, I don't know if I know that the European Union regulates a lot of other chemicals like the artificial colors, like the red number 40, which is associated with cancer. It's associated with neurodevelopmental disorders like ADHD. But I don't know that they regulate the PFAS. That's a good question. It's possible. It's something I don't know.
So I'm sure I'm not alone in sitting here thinking like, all right, well, like, how do I even know what's going on? Like, is there a test? Like, how do I find out how like infected with microplastics I actually am at this point? Like, can you figure that out? Is there a way to know?
So I do know that there are some good tests that I actually have a couple sitting on my bathroom counter right now that are for, a lot of the chemicals associated with them. So they test for forever chemicals, their BPA, phthalates, things like that. And that was through Vibrant Wellness, it's called. Vibrant Wellness. They have a toxins test. I have no affiliation with them.
Is it a blood test or how does it?
It's, I haven't done it. It's a urine test. And like I said, it's on my counter, so I haven't done it yet. But it's a urinary test. And they also do have a blood finger prick one, I think, as well. But the urinary test is usually how it's measured. And, the question is, well,
what are you going to do with that? Sorry, go ahead.
Yeah. What are you going to do with it? Well, for one, you're going to know what your exposure is, like your baseline exposure. And then you can make some changes. Like, let's say you don't have a water filter yet, and you get your water filter, and then you can measure again. I personally also think, so BPA mostly is excreted through urine. You do sweat a little bit of BPA out. Mostly it's excreted through urine though. So sweat does help if you're exercising or using the sauna, something that's going to make you sweat. You can sweat a little more BPA out. But I do think that there's a case to be made for the compound found highly in broccoli sprouts, but also in mature broccoli, sulforaphane. Because sulforaphane increases an enzyme that causes BPA to be converted into like a fat soluble into water soluble product, and it increases that enzyme. There's no direct evidence that sulforaphane does increase the excretion of BPA. I'm doing my own test to find out. I think highly, highly likely based on the fact that that very same enzyme is what causes BPA to be excreted, the one that sulforaphane activates. But we do know that sulforaphane activates, so that enzyme is part of what's called the phase 2 detoxification enzymes. And those enzymes detoxify a variety of chemicals that we're exposed to, including air pollution, things like acrolein or benzene. And studies have shown that people that take sulforaphane increase their benzene and acrolein excretion by like 60% after 24 hours. So it's very potent at helping you excrete a variety of chemicals that are detoxified through that pathway, which BPA is one of those chemicals. And there's also animal evidence showing that animals given sulforaphane and then exposed to high levels of BPA, it prevents like the kidney toxicity associated with it. So I think if you connect the dots, highly, highly likely that sulforaphane does improve the excretion of BPA as well. More reason to eat broccoli sprouts. There's also supplements that have sulforaphane. I take one that, I think is pretty credible. It's called Avmacol. I don't have any affiliation with them, but there are clinical studies on that showing that it's got a highly stabilized form of sulforaphane. And so I'm kind of doing some testing myself on looking at, I would imagine that I'll be initially I should see more BPA in the urine, because if you're excreting it faster, you'll see more. But then eventually, as you limit your exposure, then you'll have less, right? So like as you eliminate plastics more in your life as much as you can, then you'll eventually see less BPA coming in through your urine.
To your point earlier, there's the chemicals associated with microplastics, BPA, phthalates, PFAS, but then there's the microplastic itself, right? So as the brain is accumulating these things and it's showing up in our organs, et cetera, we can take sulforaphane to hopefully detox the BPA, but the microplastic remains, and there's some indicia that in and of itself, separating the chemical aspect of it is problematic, particularly it sounds like in terms of cardiac health.
Yeah, I'm glad you brought this up.
And there's nothing you can do to get rid of it, as far as I know. Is that?
Well, I'm glad you brought this up because so the microplastics, once they make their way into your circulation, they go to your organs, like there's no way out. Right? I mean, it's like little particles, tiny, tiny particles accumulating in your organs, right? But when you're ingesting them through water or foods or whatever, sort of thing that you're eating, there is some, I would say, preliminary evidence that dietary fiber may help prevent the absorption of those microplastics. So what happens is, the microplastic particles, first of all, depending on the size, if they're really, really small in size, like the nanoplastic size, they can transverse against the gut epithelia and sort of get absorbed very easily and quickly. But the more dietary fiber you're eating, both the fermentable and non-fermentable. So the non-fermentable type of fiber would be the kind of fiber like found in vegetables that just move stuff through you, right? So the more you're moving stuff through you, the less of a chance the microplastics have to stay around in your intestines and be absorbed. So dietary fiber that's non-fermentable can help with that. But fermentable fiber also helps, and it also helps with the very, very small particles because fermentable fiber, so this is the kind of fiber that used to be called soluble fiber that, our gut microbiome is fermenting into all these beneficial short-chain fatty acids. Well, that type of fiber forms like a very viscous kind of lining that encapsulates these microplastic particles. These have been done in animal studies, by the way. This has been worked out in animal studies, and encapsulates these microplastic particles and helps move them through so they're not absorbed through the intestinal tract. And so I think there's an argument to be made for yet another reason why dietary fiber is beneficial, in that it's helping prevent the absorption of the microplastic. Because that's the only, once it's in your circulation, it gets to your organs. And I don't know of any way out.
It's not getting out.
It's not getting out. That no one's come up with the way of that yet that I've seen. So, or I can even think of.
And everybody should be eating a lot of fiber anyway.
Right.
For a lot of reasons, right?
Yes. Yeah.
What was the most surprising finding in all of this?
For the microplastics?
Maybe you didn't expect,
The brain, for sure. The accumulation in the brain was incredibly disturbing to me. I mean, 10 to 20 times more than other organs. I mean, to me, it was like, oh crap! Like this is coming in through inhalation and through oral consumption. It's like a 2-pack punch again. You're getting, and it's going into the brain. And I know how detrimental neuroinflammation is for brain aging, for also mental health. Inflammation's been shown to play a causal role in depression as well. So when you have something that's just sitting around in your brain and it's like this tiny little producer of just inflammation, it's just inflammation, and then it's accumulating. The more you get, the more compounding effect it has. It's very disturbing to me to think about. And so I would say I'm acutely aware of clean air, the air I'm breathing in. Also there's all sorts of studies that have come out of, cities with really bad air pollution, like Mexico City. There's been a few studies that have come out looking at, postmortem, like infants and also children. Their brains have accumulated amyloid beta plaques, like an 80-year-old would have. These are things that are involved in the pathology of Alzheimer's disease that should in no way, shape, or form be in an infant or a child brain. And so it's really indicative that the air pollution is playing a role in Alzheimer's disease. And again, air pollution comes with, there's a whole host of particles and stuff that are particulate matter, that microplastics are involved in that. They're in that whole sleuth of, particulate matter. Microplastics are in there. And so air pollution is now really, I think, is now increasingly being recognized by a variety of neuroscientists as playing a pretty substantial causal role in Alzheimer's disease. So you have to think about that as well. We live in the more urban environments that we're living in, especially if you're living in a city that's has more air pollution, or also if you live close to a busy highway, right? I mean, that's something to consider as well, particularly with prioritizing getting a high quality HEPA filter, multiple HEPA filters perhaps in and around your house, so that you can at least filter out the air when you're at home. And also trying to spend more time in green space, that it's also important.
Plastic is so ubiquitous and it's relatively new. It's a new introduction to humanity, and it just continues to kind of like monopolize like every consumer product and food product, et cetera. And it feels like and to understand like, oh, wow, like we're accumulating this, it's passing through the blood-brain barrier. We're running this massive experiment that we don't really know. There hasn't been has there been a generation that has been raised from day one, in this world of plastic being as ubiquitous as it is, up to the age of like 80 or 90, where we can really see like the long-term impact of what this is. It feels like, all right, well, we're accumulating all this microplastics, but like, I don't know, I feel okay, like I don't have cancer or what, so I guess we don't know, right? That part of it.
Well, that's part of the insidious damage, right? Where you can't, you don't look in the mirror and see that your like gums are falling apart and you have scurvy, right? It's like this little bit of damage, and it's happening every day and compounding as it accumulates. You're accumulating more of it, right? And that's part of that insidious damage. I would say we do know from, environmental exposure, at least, not necessarily with microplastics, but with the plastic-associated chemicals. Certainly like the forever chemicals, firefighters, the foam that they use. That's like one of the major pollutants of forever chemicals in our environment. And firefighters have a astronomical increased cancer risk. The flame retardants, so anything that's like water repellent, oil repellent, the flame retardant, like these things have forever chemicals in them, and they're carcinogens. And so in a way, I made that analogy like earlier in the podcast, we were talking about Alzheimer's disease, and I made the analogy of traumatic brain injury being able to I feel like in many ways study Alzheimer's disease in real time, where it's like brain aging happening in real time. We can look at some of these people that are working in environments where they're being heavily exposed to some of these plastic chemicals and go, look, these people are getting really high levels. They're being exposed to a lot of them at once, and it's not good. So I think lessons to be learned from that, right? And so, or like even with, Aaron Brockovich and that whole story, right? I mean, you've got like people that were exposed to astronomically high levels of some of these terrible chemicals, and, it was causing terrible health effects. There was a story, I think it was published in like the New York Times a few months ago on these organic farmers. Their farm was contaminated with the forever chemicals, the PFAS, and the kids were all getting sick, really sick, and the parents couldn't figure out what's going on. Like, why are the kids getting so sick? And finally, it came down to their soil was contaminated, and the cows that were grazing on their soil, that were feeding their family, were excreting all these forever chemicals in the milk, and the kids were just eating, getting high levels of it. So again, I think that, we are running this experiment. But in parallel to that, I think that we can look at, some of these environmental health hazardous kind of occupations where people are exposed to much higher levels and say, okay, well, what happens when you increase the magnitude of that exposure? Causes cancer. It's not good, right? And say, well, we need to do something about this, because this insidious damage, while we can't see it right now, decade from now, 2 decades, 3 decades from now, maybe we are. And then not to mention development, right? Pregnancy, that's a very, very sensitive period. And that's when, microplastic particles are found in the placenta as well. In fact, the study that looked at the placenta only sampled 4% of the placenta, only 4% of the whole placenta, and found about 12 microplastic particles in 4% of the placenta. So imagine how many particles are in the entire placenta. What are they doing? And we know they cause inflammation. That we know. They increase inflammatory cytokines, and it's not good. There's again, going back to the autism link, I mentioned the BPA. There's studies showing that like mothers that have a feverish response during pregnancy, so they have a fever, very activated immune response, a lot of activated cytokines, much more likely to have a child diagnosed with autism. So there's a connection here, right, between inflammation and the immune system and some of these chemicals and the microplastics and development and particularly neurodevelopmental disorders. I mean, like this is a very sensitive period. So I think more than anything, that is the time to be the most fastidious in terms of get a little bit crazy during that time, get a little bit neurotic, be a little bit worried about plastic for those 9 months. I think that's the time, if any, to do that.
But as soon as you become fastidious, you quickly realize like how difficult it is to sidestep this. Like even the natural products are generally packaged in plastic. Like if it's a deodorant or whatever, it's like it's really hard to like go do an end run. Like how rigorous are you in your own life? Like now you've got a brain full of like all of this information. So every time you go to the store, you must be like, okay,
yes,
like,
well,
how do I do this? It doesn't come in glass,
When it comes to things I'm putting in my mouth, like that's where I'm most concerned about trying to avoid the plastic. If it's a fruit that's in a plastic, like a strawberries in the plastic container, I mean, it hasn't been there for that long, right? And so I wash the strawberries off. What am I going to do about that? It's not like tons and tons and tons of microplastic particles have shedded into it. When it comes to like my deodorant and my shampoo, I'm less concerned about it being in a plastic bottle. Really, it's really hard to avoid that. Like, let's be honest. Yeah. Like you're not going to find a bunch of glass bottle shampoos. But I am looking at phthalates. When it comes to cosmetics. So, when it comes to like cosmetics, you're not absorbing that much of like the microplastics through the skin, It's really the oral consumption and the breathing in, the inhalation. Those are the two main routes with respect to microplastics that really you should focus on, like that, the absorption through the skin. That's mostly, again, with like the BPA, if you're getting like the thermal paper, something that's really, really high in BPA, or the phthalates that are, coming in through the skin absorption. That's when it comes to like skin absorption, those are the things that I'm more concerned about. Now, yes, there's probably some BPA getting into my, shampoo that I'm shampooing on my head.
What about your toothpaste tube and your toothbrush with the plastic bristles and the plastic handle that you put in your mouth every day?
Yeah, I've gone there.
Yeah.
I don't know what to do. Like they have the bamboo handles. I don't know that the handle matters as much as the bristles, which are made of plastic.
Yeah. I have like the wooden ones too and the bamboo, but the bristles are plastic.
The bristles are
plastic.
plastic.
So you should put the plastic in your mouth.
I know. It was when I realized that, I was very disturbed, and then I started researching, and it turns out toothbrushes used to be made of boar hair, like a long time ago.
I didn't know.
I don't know that that's any better. I don't know, brushing my teeth with boar hair. But yeah, they used to be made with boar hair. But look, there's room for innovation, right? I mean, there's room for innovation here. Maybe someone's going to come in with some cool new toothbrush with bristles that are not shedding a bunch of microplastics. Fortunately, we're not swallowing. I mean, we're swishing it out. And I just try to like get the water and rinse out really good after I brush my teeth. So I'm not swallowing all the microplastics,
Yeah.
You're going to absorb only a certain amount through. I can see you're kind of like me where you start to go down the rabbit hole.
It's like a part of me doesn't want to think about this that much.
Of course.
Because you could turn into a crazy person and become like a recluse.
And you shouldn't.
And just, you don't want to live your life in fear. And some of these things there is no toothbrush that doesn't have plastic bristles as far as I'm aware.
Right. So let it go. And try to, not heat up the plastic in the microwave, and try not to drink plastic out of something that's been heated, and try to get a water filter and get an air filter and do the things that you can do, but then let other things go. Like, if you're exercising, and you're doing a lot of, you're eating healthy, you're getting your vegetables and your fiber, and you're eating the sulforaphane, and you're doing a lot of the important things, you're getting good sleep, like you're really doing as much as you can, right? So you can't, I don't want to do the fear mongering either, but I do want awareness to be had. I do want people to be aware of this problem and to think about it, because it is a problem, and ignoring it's not the answer either. But going insanely crazy and neurotic about it is only, stress. Chronic stress is probably one of the worst things that you can do for your health. So stressing yourself out about it is probably not going to be beneficial either. I think if you're doing the main things with getting a good reverse osmosis filter, getting a good air filter, and avoiding drinking, heating anything plastic is the main thing. But, to the most that you can, try not to drink out of plastic water bottles, and the food that you're consuming, the hot plastic foods, try not to do it every night. Like, you get takeout once in a while, fine. But maybe try not to get takeout, every night.
Yeah. I know you have a lot of resources on this on your website and obviously in your podcast. Are there consumer watchdog groups out there, or other kind of like NGO type resources online where people can educate themselves? Like, what's the best place to direct someone who's like, oh my God, I want to learn more about this?
About microplastics?
Yeah.
So I did do a podcast on microplastics. And so you can find that in my podcast. But I do think that if you're wanting to look, I don't know about, education-wise, but I know that consumer-wise, if you're looking for, if you're trying to find if your products that you're buying are contaminated with perhaps like heavy metals or some of the plastic chemicals like PFAS, so Consumer Reports, Consumer Lab, they do a lot of third-party testing. Or like if you're looking at the sparkling water you're drinking, you want to see, I want a list of the best sparkling waters.
Yeah, it's the brand by brand. Like if you're going to choose one, which one? Right.
Well, for me, I like Mountain Valley's sparkling water or spring water in the glass bottle, but also Pellegrino is one of the lowest PFAS chemicals. But again, that was Consumer Reports. So they do, you can go to these third-party testing sites to look for a variety of brands that have been, at least vetted for having, fewer amounts of some of these plastic-associated chemicals like PFAS. which I think is useful for anyone that's like, okay, I want to try to at least, make sure I'm getting.
But there's no like microplastics.org where you can go and like double check like every product that you want to buy against its potential risk or something like that.
I don't know. I haven't looked into that.
Somebody should start that.
Someone should start that.
This is the second business idea I'm giving you today. One's going to make you money and one's going to require you to spend it on.
Right.
All the money that you make on your exogenous lactate, you're going to have to dump into microplastics.org. Well, I think that's a good place to end it. I mean, there's obviously tons more, but you go into such depth and such detail in your podcast and the materials that you make available. So for anybody who's listening to this whose interest has been piqued, yes, please venture over to Rhonda's territory of the internet. She has plenty of stuff for you.
Yeah, foundmyfitness.com is my website, and the podcast is called Found My Fitness. I'm all over YouTube.
You're in all the places,
Spotify,
and on YouTube,
places,
and all the kind of stuff.
Yep.
And what's your next obsession? Are you diving deep into some project where you're going to emerge with a new video that's going to blow everyone's mind about something we haven't thought about before?
Oh, something you haven't thought about.
What's the research that you're reading right now that's like getting you excited?
I do have a podcast I'm coming out with on protein, but I think some of the research I've been reading about creatine's got me excited. That's probably, especially with the effects on the brain. Mm-hmm. So that's kind of an upcoming one as well. But I don't know yet. I gotta figure out what my next, where it's going to take me next. I'm not sure.
Well, when you figure it out, come back and tell us all about it.
Would love to, Rich.
Yeah. Thanks, Rhonda. This was really fun. I appreciate it. You are performing a public service. And so I just want to acknowledge you for that. Like what you put out into the world is important and makes a difference. So thank you for doing it, and please keep doing it.
Thanks so much. Appreciate it.
Peace.
That's it for today. Thank you for listening. I truly hope you enjoyed the conversation. To learn more about today's guest, including links and resources related to everything discussed today, visit the episode page at richroll.com, where you can find the entire podcast archive, my books, Finding Ultra, Voicing Change in the Plant Power Way, as well as the Plant Power Meal Planner at meals.richroll.com. If you'd like to support the podcast, the easiest and most impactful thing you can do is to subscribe to the show on Apple Podcasts, on Spotify, and on YouTube, and leave a review and or comment. This show just wouldn't be possible without the help of our amazing sponsors who keep this podcast running wild and free. To check out all their amazing offers, head to richroll.com/sponsors. And sharing the show or your favorite episode with friends or on social media is, of course, awesome and very helpful. And finally, for podcast updates, special offers on books, the meal planner, and other subjects, please subscribe to our newsletter, which you can find on the footer of any page at richroll.com. Today's show was produced and engineered by Jason Camiolo. The video edition of the podcast was created by Blake Curtis, with assistance by our creative director, Dan Drake. Portraits by Davey Greenberg, graphic and social media assets courtesy of Daniel Solis. And thank you, Georgia Whaley, for copywriting and website management. And of course, our theme music was created by Tyler Pyatt, Trapper Pyatt, and Harry Mathis. Appreciate the love the support. See you back here soon. Peace. Plants. Namaste.